My name is Samarth Narula, and I'm going to be your instructor for today's course. I'm a principal software engineer and a microservice cloud architect. I have more than 5 years of experience in IT, as well as I'm a publisher of 2 top-rated courses on Udemy, 5 top-rated courses on Coursera, and on multiple other platforms. So let's begin our today's session. I'll start by sharing my screen. And every 5 minutes, I'll just check if new students are in the waiting room. I'll admit them in, and then we'll continue with our today's session. So this is the curriculum for day 1. Let me walk you through the curriculum. So in today's session, you're going to learn about the fundamentals in Spring Boot. Like, first of all, the first module is Introduction to Spring Boot. Then is DevTools, like how you can leverage DevTools for rapid application development. Then how you can monitor performance of your Spring Boot application with help of actuators. How you can enable profiling, model design, basically your Pojo classes design like you have in Java, similar model design. And introduction to Lombok Framework. So I'll be teaching you about Lombok Framework and how you can use Lombok Framework with Spring Boot to avoid boilerplate code. Then understanding the controller tier, how you can create controller classes and your APIs. Then introduction to Swagger API. Basically, instead of testing our APIs from Postman, we are going to test our APIs with help of Swagger API. That's why we'll be configuring the Swagger API in today's session. Then some advanced concepts like some design patterns and how you can use the Lombok annotations to avoid boilerplate code even further than most techies can imagine, like how you can write a all args constructor with help of this annotation, how you can just enable a default constructor with help of this annotation, and much more, like builder design pattern with help of this annotation. Instead of writing so much boilerplate code of builder pattern or generating boilerplate code of builder pattern, you can avoid all of that with help of this Lombok annotation. You'll see that in today's session. Then understanding the service tier, how you can create service classes in Spring Boot. Then embedded database H2, how you can leverage embedded database H2 for creating your POCs and POTs and for your temporary data storage requirements. Then what are entity classes, how you can map your Java Pojo classes basically to database classes, or you can say database tables by enabling the entity classes, like how you can convert your Pojo classes to entity classes so that they get mapped to the database table. Then JPA, like we are going to use JPA for performing CRUD operations onto our database table. Then exception handling in Spring Boot. Then one step ahead, like creating custom exceptions. Then even one step ahead, like creating custom exception handlers in Spring Boot. This is very interesting part, okay? And after that, we are going to learn about the Microstream. So you must be aware this training has been sponsored by Microstream. So we're going to learn the Microstream module also, and I've created a Spring Boot Microstream integration project for which I am going to provide you walkthrough for. This is about day 1. And tomorrow, you're going to learn these things, like you're going to learn Hibernate. I'll give you detailed walkthrough about tomorrow's curriculum tomorrow only. So you're going to learn Hibernate tomorrow, then Spring Boot AOP. So with help of Spring Boot AOP, while learning Spring Boot AOP, I'll teach you how you can enable audit system. Then Spring Security. In Spring Security, we are going to cover a lot of different things, like how you can enable JDBC-based authentication, how you can enable in-memory-based authentication, all of those things, and how you can enable encryption and decryption. So I'm going to use Bcrypt, which is a single-way encryption algorithm. Then in Spring Cloud modules, we're going to cover configuration management. So this is your day 2. These things you're going to learn tomorrow. And today we are going to focus on the fundamentals. All right. So let me admit few more students in, then we'll begin our today's session.
Yeah, hi, Narula.
Hey, hi.
Can I ask one question?
Sure, Nitin.
Yeah, actually, after completing this course, you will provide a certificate for us or not?
Certificate is not included in today's session, but you'll be getting all the content that I'll give you walkthrough about, and you can reuse that content in your office work to rapidly do your office work. Like that content would be your base on top of which you can build your office projects. or you can complete your work.
Okay, thank you.
Can I ask you a question, please?
Sure, James.
Okay, I just want to ask, will there be a break? Kind of like I'm saying this will be a very long class, so will there be a break?
Yeah, there are going to be small breaks. After
Okay.
covering, let's say 2 or 3 topics, we will take a break of 10 minutes, 15 minutes, so that you can have your coffee break.
All right. Thank you.
All right. I'll just open my PPT. So guys, you can see the slides, right? I have 2 displays, that's why I'm just confirming. Quick confirmation from anyone. Are you able to see the slides? Yes, the session is recorded.
Yeah.
Yeah.
All right. All right. So the prerequisites for this course is you should have workable knowledge of core Java. Software required is JDK 8 and Eclipse IDE. Although you can prefer to use IntelliJ also, but in that case, you'll have to do some things differently than what I'll be demonstrating during today's session. Then it's good to have some basic idea about Maven. Although if you don't have, don't worry, I'll cover the Maven, like what exactly we are using Maven for here. Let's get started. Let's start with module 1, Introduction to Spring Boot. So agenda for this topic is Introduction to Spring Boot. So in this topic, we are going to learn what is Spring Boot, why to learn Spring Boot framework, difference between microservice and monolithic service, characteristics of Spring Boot, how Spring Boot is better than initial Spring framework. So let's understand first what is Spring Boot. So Spring is a framework, boot means bootstrap. That means you can easily bootstrap your microservice web applications by using Spring Boot framework. Let's understand again what is Spring Boot. So Spring Boot is a framework, and with help of Spring Boot, you can easily create your microservice applications, and these microservice applications are easily deployable on different clouds. Some of the famous clouds in market are PCF, which is just a platform as a service. So it's a Pivotal Cloud Foundry platform. It's a platform as a service. AWS, GCP, and Azure, these are very famous clouds, so you must be knowing about it. Amazon has this cloud product AWS, Google has the cloud product GCP, Microsoft has the cloud product Azure. So these are platform as a service as well as infrastructure as a service. Like because they are providing you infra, you can choose the region, right? In which region you want to deploy. So that is why infrastructure as a service plus platform as a service. And when you're using Spring Boot, you can easily configure your databases. So you're going to see this in today's session, how easy it is to configure your databases. You can easily monitor the performance matrices of your application, and you can easily deploy the application. So the deployment files, if you have to write some deployment file, it's very easy. Okay, now why to learn Spring Boot framework? So you should learn Spring Boot framework because it is very easy to build microservice applications with Spring Boot. And another reason is it's a very popular enterprise application development framework in the industry right now. So there are a lot of jobs which require you to have this skill, Spring Boot framework skill. So if you know Spring Boot framework, they'll easily hire you. So you can, outstand in the crowd. It helps you to write. And next is like why they are using Spring Boot is like it helps you to write high performance, easily testable, clean, reusable, and maintainable code. And you'll realize it today when you'll see like how easy it is to build microservice application, or how easy it is to build APIs with help of Spring Boot framework. And on top of that, it's very easy to deploy the Spring Boot application jars on different clouds. Now let's understand the difference between microservice and monolithic service. So let me ask you, some of you must be aware about what is monolithic service. So can someone explain like what is a monolithic service?
I think monolithic service is an application that you build inside Java code, like without without extension to maybe a React framework or an Angular framework. An Angular front-end application. Like it's just something that is built together with the Java, like just like using TimeLeaf or GSP. I don't know if I'm right.
Okay, and what do others think?
You said?
Okay, go ahead. Admit few new students. All right, so I'll explain you the difference. So in a monolithic service architecture, generally all your functionalities are part of your same application. So you can imagine an e-commerce application which has a payment functionality and add to cart functionality. And if it's a monolithic service, your payment functionality and your add to cart functionality will be part of the same service. Okay, it will be part of the same application. Now, what will happen? Let's say if this application goes down for any reason. In that case, your payment functionality will go down as well as your add to cart functionality will go down. So this is the drawback of using monolithic service architecture. Now, how do we overcome this drawback? We overcome this drawback by using microservice-based architecture. In a microservice-based architecture, these two functionalities are decoupled into two different microservices. So there is this one microservice which is payment application, and this another microservice add to cart application. Now, even if the payment application goes down, still you'll have the business continuity because your customers who are using your UI for purchasing products will still be able to add the items to the cart, but they won't be able to make payments right now, but still they will be able to add the items to the cart. And when your payment application comes back up, they can then complete the payment and purchase the application. So this is how we can say that microservice architecture overcomes the drawbacks of monolithic application. There are many more examples, but I've just taken this one. Now let's understand the characteristics of Spring Boot. So the first characteristic is it's the opinionated framework. Why is it an opinionated framework? Spring Boot is an opinionated framework because there are less configurations and more of conventions that you have to follow when you're using Spring Boot framework. So that's why there are some opinions about it, that like, why are there so many conventions? But then some people say, okay, at least there are few configurations that we have to do. Since there are few configurations, your focus is more on writing your business logic. So that's another advantage of using Spring Boot framework. Like majority of the configurations are handled at the framework level. So you can focus on writing the business logic. All right. Guys, you will be getting the recorded video. Don't worry, but only if you attend the session for the entire day. Okay. Next characteristic is start with something. So when you're using Spring Boot framework, we basically create the skeleton Spring Boot framework with help of Spring Initializer. Because of that, we start with something. We have a base skeleton project ready, and we can directly import that project and work on it. That is why we say we start with something. Now, once you start with something, you can always tweak it later based on requirements, right? If you want to, let's say, you want to create new functionality, you can tweak your application and create the new functionality. Also, the Spring Boot applications are standalone. That is because if you add the web dependency in your Spring Boot application, it gets the embedded Tomcat server. And because of that, it becomes a standalone application. Because you have the embedded Tomcat server, you can just right click and run your main file, and it would start an embedded Tomcat server that you have in your application. And Spring Boot applications are production ready. So they are called production ready because they're easily deployable on different clouds.
Samarth.
Yeah, go ahead.
Yeah, I have a question. Like, what exactly do you mean by standalone? When I say
Standalone
something that,
basically is like, okay, so in general, when you have the old Java application in which, let's say, you want to deploy your application onto some server. So in that case, what you do, you build the war file or a jar file of your application, right? And you place it in the Tomcat some directory, or maybe if you're using JBoss server in particular directory, and then you have to restart your server and then it deploys the application, or maybe restart or run that application after placing it there, or you have some pipeline. When you place it there, it picks it up and runs it, right, in your server.
yeah,
So that is when you have to do, because you don't have the embedded Tomcat server. You cannot just directly run that kind of a code in your local. That is why you have to deploy it and run it. But Spring Boot application you can run in your local, you can test in your local, because it has the server embedded in it. You'll understand it when we go to the H2 part, because I've drawn a diagram in which I show like this is your Spring Boot application. Inside this you have your embedded Tomcat server. Inside your embedded Tomcat server you have your embedded database, and how that like how it exactly works, you'll understand it in that session because of the diagram that I've drawn. Okay.
yeah, okay, yeah. Thank you.
Okay. So let's summarize what you've learned in this session. So in this session, you have gained basic idea about what is Spring Boot framework and why we should learn it. And then we have also learned about what are microservices, then what are monolithic service, and difference between microservice and monolithic service. And you've also learned about the characteristics of Spring Boot framework. Then you've also understood how Spring Boot is better than initial Spring framework. So let's understand this part. I think we skipped this part, right? How Spring Boot is better than initial Spring framework. So there was this Spring Core framework. It was a huge framework. It had multiple configuration steps. So even for configuring your database or for any configuration, you had to do multiple steps. So it had multiple configuration steps, and handling dependency management is to become difficult as your application is to grow. So all these drawbacks have been overcome with help of Spring Boot. Why? Because Spring Boot abstracts out these configuration steps at a framework level for you. So you can focus more on your business logic. Okay. Since Spring Boot framework handles the majority of the configuration part for you, and you just have to write few lines for configuring a new thing. Because of that, you can focus now more on your business logic rather than writing configurations. So that is how Spring Boot is better than initial Spring framework. And also in Spring Boot framework, you have to write very less code, and with very few lines of code, you can do a lot of stuff, which you're going to see today. So better you will understand when I will start the practical. So don't worry too much about the theoretical part. I just wanted to give you little context about what is Spring Boot framework. Majority of the things what you're going to learn today will be practical based. And when you'll see something, you'll understand it better, right? That's the way people learn. When you see something, you understand it. So majority of my course, the rest of the modules are all practical based. All right. Now let's summarize this theoretical topic. In this video, in this session, you have gained basic idea about what is Spring Boot framework and why you should learn it. And then you have also learned about what are microservices and what are monolithic service and difference between microservice and monolithic service. Basically, you have understood like how Spring Boot is better than initial Spring framework, right? All right. Now let's start with the practical. Enough of theory. Let me admit few more students in. All right. Meanwhile, they are joining. Okay. So in this module, like introduction to Spring Initializer and creating a project with Spring Initializer, what we are going to do is we are going to create a skeleton Spring Boot project by using Spring Initializer. I'm going to show you how you can set up the Eclipse workspace. Then import the generated skeleton Spring Boot project in Eclipse IDE. And some easy steps for fixing common build issues. Okay. I'm showing this for the people who are very new to Eclipse IDE and are very new to Spring Boot. Okay, let's navigate to Spring Initializer. So this is the URL for your Spring initializer, start.spring.io. And here you can bootstrap a skeleton Spring Boot project. So first of all, for bootstrapping, you have to select the project type. So we are going to use Maven project. You have the option of choosing Gradle also, but I use Maven. So I'm just selecting this Maven over here. Then language will be Java. So you can create your Spring Boot application in these three languages, Java, Kotlin, and Groovy. So we're going to stick to Java. And Spring Boot versions. So these are the latest versions that we have right now. So we'll select this one. By default, it is selected 2.7.0. Although I feel it's not very stable, we are going to use a different version. The latest versions are not compatible with Swagger dependencies. So I've chosen to stick with this version of 2.5.6 or 2.5.3. Let me show you in the POM file. I have it. Meanwhile, it's opening. Let's navigate back to browser. Okay. So we are going to select a different version, which is more compatible with all the different dependencies that we have in our project. And here you have to write your group ID and your artifact ID. One thing to remember is artifact ID is your project name. So whatever artifact ID you give the same over here. The name and artifact ID should be same. Like artifact ID is like if you do that Maven clean install, it will build your application with this artifact ID, which you mentioned here. And this name is what you'll see in your Eclipse IDE. Then you can give a description for your project and the package name and the packaging type. So we're going to use jar file, although there is no deployment included in today's course and in tomorrow's, like in overall in the Spring Boot 2-day course. So there is no deployment included in your curriculum. But if we finish everything, I might demonstrate that how you can deploy on AWS. Then Java versions, these are the Java versions that we can use. So we are going to use Java 8. And then you can add dependencies by clicking this add dependencies. So let's say if you want to add web dependency, you can just select write web here and select this Spring Web. So you were asking, right, how you get that embedded Tomcat server. So you get this embedded Tomcat server because of this dependency. When you add this dependency, it also adds the embedded Tomcat server. And when you start your application, it basically deploys your application in this embedded Tomcat server, and it basically runs your application in your local. That is how you don't need an external server to run your Spring Boot applications. So all you need to do is add this dependency if you want this embedded Tomcat server. Otherwise, you'll have to build the application and run it like normal. Just place it into some other directory of JBoss or a separate Tomcat and deploy like that. Then we are going to use DevTools dependency. So basically here you can see it says provides fast application, restarts, live reload. So basically it is what, like whenever you make any change in your file and you save that file, DevTools dependency will detect that change and it will auto restart the application for you. So this happens only when you're using first of all web dependency and have your Tomcat server and have your embedded Tomcat server. So whenever you change a file, what it will do is it will detect that change and it will deploy that change in the embedded Tomcat server and auto restart the application for you. So in this way, you don't have to manually restart your application. Don't worry, you're going to see this in action. Then we are going to use let's say H2 dependency for database, and for performing CRUD operations onto the database, you're going to use JPA. And Swagger dependencies are not available here. So I'm going to show you which dependencies to use, and I'll be providing you all the projects that you're going to learn in this course. So you can directly refer that project and add the dependencies from the POM file of the projects to your Office project. Okay. And once you're done selecting all the dependencies, you can click this explore option here and see how the structure of your Spring Boot application will look like. If you feel it's good enough, you can click this download and download the project. This is one way to go about it. Or else you can directly click this generate button and it will still download the project for you. So these are the ways of generating your skeleton Spring Boot project. Once you have generated, all you have to do is you just need to go here, unzip this file. And once you've unzipped, you can directly copy this path, navigate to your Eclipse IDE, right click here, click on import, select existing Maven projects, next, paste the directory over here, click enter, hit enter, and you'll see that it's able to detect your POM file, and click finish. So you'll see that it is importing the project, and it will also download all the dependencies. So if you're going to import a Spring Boot project for the first time, it will take a lot of time for you because it's going to download all the dependencies. So I'm going to simply delete this project because I've already generated a project for you. I just want to demonstrate the process of generating a project from scratch. You can either generate a project from scratch, or you can use the project that I'll be providing you as a base project and do your office changes in that, because it will be much simpler for you to use this project once you understand it in and out in today's session. Even if you're in college, you can leverage this project to build your college project. Okay, you can change the design from bookstore to parking lot or to bakery system or any other design that you like. This is a very generic design which I've developed, which you can leverage to change the application design and store various kinds of data. Okay, let's go to the slides. Okay, so now you have seen like how you can create a skeleton Spring Boot project by using Spring Initializer. Then you have also seen how you can set up the Eclipse workspace. Okay, you have not seen this part, right? How to set up the Eclipse workspace. So after creating the workspace folder and starting this workspace folder, what you have to do is click on Window, Preference, right here, JDK, select this installed JREs and ensure that you have JDK 1.8 here. If you don't have, you can select it. If you have something else, like let's say you have Java 11 installed, you can select remove, click on add, select the standard VM, next, click on directory and navigate to your, if you're using Windows, Java, C program files, Java, and your respective JDK that you want to use for your project. So for these projects, I've used JDK 8. So you can select JDK 8 and click on the select folder. And you'll see that it's able to import all the jar files. And since I already have this JRE over here, that is why it's saying JRE name is already in use. So I can just change the name and again add it, but I don't want to do that because it will add a double jar. So in your case, you can click on finish. That is how you can link your JDK with your Eclipse IDE and then click on apply and close. Also, there is one more thing that we need to change. Click on again Windows, Preferences, type here debug, select this debug under your Java and just ensure that you have clicked this suspend execution on uncaught exceptions, because when you're using DevTools, you might see some silent exception, silent error exception when it does the live reload. That is not the problem of DevTools, that's the problem of Eclipse IDE, which you can ignore or avoid by enabling this option, suspend execution on uncaught exceptions. Once you select it, click on apply and click on apply and close. Okay, that is how you apply the change. All right, so let's go here. Now that you understand how to set up the Eclipse IDE and how to import the generated skeleton Spring Boot project. So what we did was, after generating it, we got a zip file, we unzipped it, and we imported it as an existing Maven project. That's how you import a skeleton Spring Boot project. Now, some easy steps for fixing common build issues. If you see any common build issues, what you can do is you can just go to project, clean, and clean all projects. Also, just ensure that this build automatically is enabled. Otherwise, you'll have to always build manually, like by clicking this build project. So just ensure this option is enabled. And still, after doing project clean, if it's not resolving your dependency issues, what you can do is right click on your project and go to Maven, go to run as, do a Maven clean and a Maven install. So first do Maven clean and do Maven install. This would generally fix majority of your build issues, or maybe your dependencies have not got downloaded for some reason. So it will fix this issue by when you do this. Next is, okay, so these are the things you need to do. So let's summarize what you have learned in this topic. So in this topic, you have learned how you can use Spring Initializer for creating a skeleton Spring Boot project. And you have also learned how to import the skeleton Spring Boot project and what steps are required to fix the local IDE build issues if they occur after importing the project. Okay, before we move forward to this understanding about how Spring Boot project runs, or we can say how Spring Boot application runs, there are some things that I would like you to know. The Eclipse IDE version that I'm using. So help about Eclipse IDE. So for this course, I'm using this version 2020-03. The max version that you can use for these projects is 2021-06 or 09. With the latest version, there are some issues with integrating your Lombok into your IntelliJ. Like there is a plugin. So along with like you don't have to do much configuration in your project for Lombok, but in order for the Lombok configured code, your IDEs have to do some configurations. Like there has to be some configuration at a IDE level. Okay, this is your IDE, right? Eclipse is your IDE. Similarly, you have IntelliJ or you have NetBeans. So you have to do some configuration. So that configuration is not supported in 2021 versions or maybe 2022 versions. So in 2021-06, I've used Dash and it is supported. In 09, I think it was giving issues. So Eclipse guys will fix that issue. So I'll recommend that using Eclipse IDE version max to max 2021-06 for this project. Okay. Otherwise, you'll have to drop the Lombok dependency that I've added here. This is one thing. Before we proceed to this topic, if you have any doubts, please let me know. Like any doubts in understanding what all things we have covered so far?
No, sir.
Okay. Get the recorded. Okay. Omkar, you're going to get the recorded video that will be shared by the Microstream guys with you. Aniket Kumar. Yes, Aniket, you can learn Spring Boot without learning Spring Core framework. That doesn't matter. Spring Boot, you can learn it and you can even leverage it. And after learning this, you will feel like, okay, good, I didn't learn that basic framework. I directly learned Spring Boot, because it's very easy to learn Spring Boot framework and to do a lot of stuff with Spring Boot framework. Okay, guys. So we'll take a quick break of 20 minutes. I'll start the timer on Google. So see you after the break. Let me share my screen. Hello, am I audible? Guys, okay? I'm audible, right?
Yes, yes,
Yes.
audible.
Okay. I think something wrong with my headphone.
Hello. Hello.
Yes, yes, Chandresh.
Okay, okay. I wanted to check whether the voice is coming or not.
Yeah, voice is coming.
Hi, are we starting?
Hey guys, sorry to keep you guys waiting. Actually, I was facing some internet issues. Am I audible?
Yes, yes, audible, no problem.
Okay. I hope the audio quality is not degraded. Actually, I had to remove my headphones. Like my headphones were giving issue.
Okay, Samarth, no issue.
Okay. Share my screen. Let's continue with the session. I hope everyone is back from the break. So, as part of this hands-on, as I mentioned before, our course is more of practical based, and I just give you a little bit theoretical context in the start. So let's begin with the hands-on now. The first hands-on is understanding about how Spring Boot application runs. So as part of this hands-on, I'm going to explain you the structure of a Spring Boot project, and how you can run the application in run mode, and how you can start the Spring Boot application in debug mode. Then you will understand like how exactly does a Spring Boot application runs, and then you'll understand a quick fix which can be used for a common port already in use issue. So this is your Spring Boot application. The normal structure looks like this. You have a source main Java directory, then you have a source main resource directory, and you might also have source test Java and test resource directories. Since I've deleted those directories, you're not able to see those two directories here. This is your POM file, and your POM file will have all the dependencies which you have added while bootstrapping your skeleton Spring Boot project. So the very first thing in the POM file that you need to see is this part. This is the parent tag. Here you can see the version of your Spring Boot project. So we are using 2.5.6 version for our Spring Boot. So this is the Spring Boot version 2.5.6, and the latest that we saw was I think 2.6.0, right? So that's not a very stable version. So I'm sticking to little prior version, which is 2.5.6. This version is stable with all the dependencies that we are using in this project. Since we have talked about dependencies, let's see the dependencies that we are going to learn about. So this is the actuator dependency, Spring Boot starter actuator, and this is your dependency tag. So basically, this is a Maven file, POM file. So whenever you add these dependencies, what your Maven does is basically it will go to the Maven repo and it will search for this dependency, and it will download the corresponding jar file and place it in your .m2 folder in your operating system. So my .m2 folder is over here, C users, the current username .m2, and in repository you can see like how the project structure is like for this project. So this jar file is placed in this path. So this is the path of this file. It's like this repository or Spring Framework boot Spring Boot starter actuator, and then you have a folder with version name 2.5.6, and inside this folder you will have this jar file. So this is how all the dependencies get downloaded. As you saw for actuator dependency is here, and similarly these all dependencies are coming from these dependencies that you have added here. Now you must be wondering, I have added let's say a few dependencies here, right? I've added few dependencies here. I've added the actuator dependency, the JPA dependency, the web dependency, the DevTools dependency, the H2 dependency, Lombok, and test dependency, and the Swagger dependency. So I've just added like 1, 2, 3, 4, 5, 6, 7, 8, 9 dependencies. So how am I seeing so many jars here? Anyone has any idea why you're seeing so many jars here?
Actually, I think it will download all the dependency related to this, it will download all the jar file related to all this dependency.
Correct, you're correct. So these are called transitive dependencies. So actuator dependency, so this Spring Boot starter actuator is also a project that we are importing into our project by using this dependency from Maven repo. And this project also has a POM file in which it has other dependencies. So all those other dependencies have also got downloaded here. So those dependencies are called transitive dependencies. Now, if you want to see what those transitive dependencies are, what you can do is you can just click Control on your keyboard and click on this, and it will navigate you to the POM file of that project. So this is the POM file of your actuator project. you can see that whoever has built this framework or this library has used so many dependencies, right? So this is exactly what you mentioned. So this is called transitive dependencies. What you are seeing here, the extra dependencies, they are coming transitively from the dependencies that you have added. So for actuator, if you open it, these are the transitive dependencies in actuator. It has this Spring Boot starter, AMQP and AOP and Artemis. So these are the dependencies that this actuator project has. Similarly for JPA, if you again control click on it, you'll see all the transitive dependencies for JPA. So it has a Spring Boot starter data, JPA, Spring Boot starter data, LDAP, MongoDB, R2DB, Redis reactive. So this is the meaning of transitive dependencies. The other dependencies which are required by this dependencies are also gets downloaded and placed in your .m2. And that's the reason why you're seeing so many dependencies here in spite of adding only 9 dependencies in your com file. Okay, now let's expand the source main Java directory. So this is your base package com.microstream. Inside your base package, you have your main file. So this Spring Boot Bookstore design application is your main file. So as part of today's course, what we're going to do is we are going to basically today create a bookstore application. So we're going to design a bookstore application in which we can store books, we can fetch books, and we can query on basis of book names or maybe library names. So not libraries, let's say bookstore names. So whenever you go to a bookstore, what are things you have? You have a bookstore name, you have certain books, and those books also have some names, right? So I've created a simple use case so that you can focus more on the concepts and learn the concepts rather than focusing on the business application design. So my core focus here is to make you understand the concepts and not to complex the design so much that your focus moves from the concepts understanding to business focus, like business application design understanding. Okay, so this is your main file. We'll come to this auto wired part later on. So this is your main file. It has the main method. And here I've just implemented command line runner and overridden the overridden the run method so that I can do a quick testing of this application. We'll understand how you can quickly test your application in the later part of the topics. In the later topics, we'll be demonstrating like how you can use it. Then I've created a config package. So by default, whenever you create a skeleton Spring Boot project, you only get the base package and the main file. And in that, you don't even get this and not even this and not this. You just get the main method and these two only and this annotation, not even this annotation. So I've added these additional annotations here. Okay. This is the only thing that you'll get when you will create a project from scratch. Now I've added some additional packages. I've created a config package, a controller package, an entity package, exceptions package, model package, repository package, service IMPL package. Now, if you observe one thing in the package naming, I have used this base package name .config for creating a config package. Similarly, for creating a controller package, again I've used this base package name com.microstream and then .controller for creating the controller package. And same for entity exceptions. You know why I have done like this? Because it's a convention that you have to follow. If you don't follow this, your Spring Boot application, when it loads up, it will not load the classes if you have placed it in the wrong package name. So how Spring Boot application loads the classes is basically, it starts the component scan from your base package and it scans for all the sub packages. So these packages that you see like config package, controller package, entity package, exceptions package, model package, repository, service IMPL, these are your sub packages of your main package. So your component scan will start from here. It will load this class and then it will search for the base package. It will not search for the outer packages. It will just go inside. Okay, inside this Microstream folder, what all folders it sees, it will just scan each and every folder and load the classes inside that folder. So that is how component scan works. So that is why you need to follow this convention. If you don't follow, your classes won't be loaded into the Spring container when your application starts. If you're worrying too much about it, no need to worry. Just remember the convention. Always, whenever you create a new package in your Spring Boot application, use the base package name dot your package name. That's all you need to remember. Okay, let's go to this PPT. So now you understand the project structure. Okay, there is one more thing in project structure that I want to show you. Is this source main resource directory. Inside this, by default, you'll only have this property file and it is going to be empty. Okay, so here in this file, you're going to place all your configurations. Okay, now let's understand how to run the application in run mode. In order to start the application in run mode, just right click on your application, run as Java application. So you can see that my application has started on a different port. That is because of this. Let me comment this out and let me just restart the application. All right. So our application has started and it's running on port 8080. Now you can basically access the Swagger UI because I have configured the Swagger UI for this application. But this is how you start the application in run mode. So the Swagger part I'll be covering in the Swagger module. Right now you can see that this is how you start your application. This was one way. In your left side, you can just do right click, run as Java application. Now I'll terminate the application, clear the logs, and I'll show you how you can start from your main file. This is the main file. I've opened the main file here. You can right click in the main file, select this run as Java application. These are different ways of starting your Spring Boot application. So we are starting our application right now in run mode. All right. Now how to start the application in debug mode? Same way, like right click. Instead of run as, select debug as and select Java application. Remember, I'm selecting Java application and not debug server or run server. Because I don't need to run this application on server. You can see when this application starts, it has the embedded Tomcat server in it. And in that embedded Tomcat server, our application is running on this port. So you can see Tomcat initialized with port 8080. So right now we have started our application in debug mode. And if you want to see the PID associated with your Java application which is running, so this is the PID. So now you also see this pop-up, right? You're seeing this pop-up because you started your application in debug mode. It is asking you if you want to switch to your debug perspective. So you can click this switch and it will switch to your debug perspective. In debug perspective, you can see you are seeing your variables tabs, your breakpoints, your expressions. So I'll just close it for now. And you're seeing the silent exit exception also. So you can just simply ignore it, click on this run. This exception you're getting over here, this is because of the DevTools dependency that we have added. In order to avoid it, let me just confirm the preference, debug, and suspend execution. So just uncheck it. So I mentioned to check it, but you have to uncheck it. So just uncheck it and click on apply and close. Now just terminate the application. Let's run the application again and let's see if we still get this silent exit exception now. So right click, debug as Java application. Now we'll not get that that silent exception. We were getting that silent exception because this checkbox was checked. So you need to uncheck this checkbox which says suspend execution on uncaught exceptions. This is your Eclipse specific issue. It's not a problem with the DevTools dependency. Okay, so you can see that we have started our application successfully in debug mode now. Let's terminate the application and clear the logs. And let's navigate back to the slides. So now that you have understood how to run the application in run mode and how to start the application or we can say how to run the application in debug mode. And you have also understood how Spring Boot application runs. So how Spring Boot application runs is basically it starts the component scan from your base package, and it scans all your sub packages and loads all the classes in your sub packages. So you need to follow this convention always. Whenever you create a new package, note it down. Just use the base package name dot your package name. Whenever you are using Spring Boot, just remember this convention. Okay. Now let's also understand a quick fix which can be used for common port already in use issue. So right now we have not seen this issue, but let me just create this issue and I'll demonstrate. So we don't have the jar file. I'll just simulate this issue that you can get. So let me do Maven install. I'm just building the jar file of this application. Okay, let's confirm it. We have the jar file. Let's open this target folder. Let's open this. Let's open command from here. Let's run this java dash jar file name. So we are starting the application. So since we are starting the same application, our port 8080 will be in use. Now I'm going to show you, like if you try to start the application again, you'll see that issue of port 8080 already in use. So this can happen, let's say, because you were doing something and suddenly your electricity went off or your laptop switched off, and this port remained in use, and you can't terminate it anymore from here. In this kind of a scenarios, what you can do, I'm going to demonstrate that. But let me just demonstrate the issue first. Now that the port 8080 is already in use, and if I try to start this application, you will see that it will say port 8080 is already in use. Okay, now you can see here application failed to start. Description: web server failed to start. Port 8080 was already in use. So we have simulated this same exception, like error again. So port 8080 is already in use. So it says action is for you to identify and stop the process that's listening on port 8080, or configure this application to listen on another port. So how do you configure the application first to listen on another port is, you can use this property server.port equals to 8081. Now that you have added this property, now when you start your application, it will run on port 8081. So we are basically, I'm showing you the first way. This is the very easy way in which you can just change the port on which your application will run on. If you get this port already in use issue on your production server, do not terminate the application if it can be some other application which is running on that port. In this case, you can just change the port number of your application. Okay, now I see that okay, port 8081 is already in use in my laptop. So in this case, I'll show you the second fix now, how you can fix it. Let me first show you like how you can start your application. Let's see if port 8082 is already in use. So I'm starting the application now on port 8082. Guys, the font size is good enough for you to read, right? Just let me know if you face any issues in understanding the fonts, like the font size is too small or something, and increase the font size.
I think it's okay, Samarth.
All right. So now you can see that application has started on port 8082. So we have launched this application on different port which is not already occupied. So this is one fix. Now in order to fix that same issue, like port already in use, what you can do is, let me start this application again and show you the issue. So by default, Spring Boot application starts on port 8080. That's the default port for your Spring Boot application. And you can configure your Spring Boot application to run on a different port by adding this property, which I just demonstrated, server.port equal to your port number. All right. So again, I've just configured the application to run on the default port, and since that port is already in use, we're getting this error. Now let me show you this first fix, which says I identify and stop the process that's listening on port 8080. We can identify the process from here also because we see the PID here. So let's see the PID here. So PID is 9476. We can use this, but let's say you don't have access to this terminal. You had started it long back. Now how do you fix it, right? So in this kind of a scenario, what you can do is you can use your Windows PowerShell or your command prompt. Right click, run as administrator. Use the command netstat -ano find string str. In double quotes, write PID space colon 8080. So here you can see that I'm getting the PID here. So it's running on my local address, the IP address of this laptop, which is 0.0.0, because that is how it shows your local address. And the PID is 9476. If you want to free this port 8080, what you can do is you can kill this process by writing here kill and the PID number, which is 9476. And this is how you can free your port. Now, if you go back here and if you try to start your application, you can see that this time application has successfully started and it's running on port 8080. So this is how you can change, you can fix the port already in use issue, but be careful if you're doing it on a production server. As I mentioned, that can be used by some other application in your project. Just ensure that no one else is using that port to deploy the application and then terminate it. Now we also saw that our port 8081 was in use, right? So let's try to change it to 8081 and replicate the issue. We should get that error again that port 8081 is already in use because we have freed the port 8080, but we have not yet freed the port 8081. So let me ask you, like now you know the process. So what are the steps for fixing this issue? The best steps that you can use. Anyone?
We can identify that process with that ID and we can kill that in command prompt.
That's correct. So you can identify the ID and you can kill it. So you can just do this from here. Like if you want to identify also, you can identify the PID from here. This is much simpler way, right? Now you can just write here kill 2076 and click yes. So it will terminate the application. Now you can start your application on port 8081. I'm showing you these edge cases because these are the things that students generally struggle with when they are starting with learning Spring Boot. So I'm showing you so that you'll not struggle so much when you'll do your self-learning. So these are the common issues where your time can get wasted, and I'm showing you the fix for it. Okay. Now you can also open the command from where we had run the Java jar file, and here also you can see that the application was terminated because we had terminated, we had killed the process associated with this running application. So it automatically stopped. Okay, so this is the quick fix which you can use. So quick fix was not this. Quick fix is to change the port number, but along with the quick fix, I've also shown you the best fix, right? Which is by using PowerShell and using this netstat command. I would advise you to make a note of this command and keep it handy. I'll also show you a trick like how I keep track of so many commands. I work as a DevOps engineer, I work as a cloud engineer, and also a backend engineer. So how I keep track of so many things. The best way is to do documentation. So you can always keep your things, the commands on Keep. So I keep my Git commands, operating system related commands, AWS CLI, EKS related commands, and all these things on my Keep. So you can leverage this and keep your open source things here for your quick reference. And you can leverage it if you forget the commands, because if you're doing hundreds of things, you can't remember hundreds of commands for hundreds of different technologies and frameworks, right? So you can always make note of it. Once you have done it, make a note of it and reuse it when you have to do it again. This is the best way to go about it. Also, I didn't share my website link with you. I've although not updated this website link from last 1 year. So currently I'm a principal software engineer at Atlin, but here I've just mentioned my previous company. So I'll just share this link with you. You can just access this link. You can go to my Udemy courses also from here. I've not added Coursera one, but you can go to my Udemy profile from here. So I'll share this with you so that it's accessible. Also, let's come back to this course. So now that you have learned this quick fix, it's time to summarize what you have learned as part of this session, as part of this hands-on. So as part of this hands-on, you have learned how the structure of generated skeleton Spring Boot project looks like, although I've just shown you some additional things because there were some additional packages. But in general structure, you'll just have this base package and this main file, okay? And you've also seen the procedure for running the application in run mode and debug mode. You now know that Spring Boot application has an embedded Tomcat server. So you saw that whenever we started our application, it was running on a particular port, which was initialized by Tomcat. So our application has the embedded Tomcat server. We didn't have to do anything different for deploying our application onto a server. We had the embedded Tomcat server, which we have leveraged. And we got that embedded Tomcat server because we have added the web dependency in our project. And we've also learned like the configuration required for changing port number. So the configuration was server.port property, which you can add to your properties file, application.properties file, and change the port number. And if you get that port already in use issue, you can change the port number, which is a very quick fix. And the proper fix is to free that port. So you can free the port by using the netstat command, which I've just demonstrated. So this was a part of this hands-on. And the next module is dev tools. Before we begin dev tools, any doubts about this hands-on that you have just learned? This is the foundation. So these things should be clear before we proceed further. If everyone is clear, you can write clear in the chat and I'll move to the next hands-on.
Samarth, I have an issue. Like when you have run that application, you got that in run mode Java application. Generally, we get run as a Spring Boot application. So why you are not getting that?
That is, it's the same thing. If you're using Spring Tool Suite, you'll see that run as Spring Boot application because Spring Tool Suite IDE is specifically meant for running Spring Boot applications, whereas in IntelliJ is meant for running all different kinds of Java applications. That's why you're seeing this generic option. It's just the IDE was designed like that, like run as a Java application. So if you're using Spring Tool Suite, it will be run as a Spring Boot application because that's IDE is designed for running Spring Boot applications only. It's just a generic name that they have given, nothing specific.
Okay, okay.
Okay. All right. Good to see that everyone is understanding. Let's proceed further then. Let's go to this DevTools hands-on. So in this hands-on, I'm going to show you like how you can configure DevTools, and I'm going to give you the basic understanding of DevTools. And DevTools is a very basic dependency, so basic understanding is all you need to have. All right, without wasting any time, let's get started. Again, I'll just comment out this property. Now, when I'll start my application, it will run on port 8080. I'll close the POM file. I've just kept the main file open. I'll close the main file also. First, I'll open the POM file. And in POM file, let's scroll down. So this is the DevTools dependency that we have added. Group ID is this, org.springframework.boot. Artifact ID is this, Spring Boot DevTools. And the scope of this dependency is runtime. And this optional is just, this is how you have to add basically the DevTools dependency. In order to understand DevTools, first I'm going to remove DevTools dependency from here. So I'm just commenting out this dependency. So you can see it says building on the right corner. So it doesn't build it so quickly. So I've removed the DevTools dependency from the project, and let's start the project. So let's open the main file, and here I'll just add a sysout statement. Inside this, I'm going to write, let's say, welcome to learning Spring Boot with Samarth, sponsored by Microstreams. All right, let's start this application. So there's a keyboard shortcut which you can use, which is Alt Shift X, and you'll see the options here. Now here you can see run Java application is if you press J, now it will run, or you can just click here, run Java application, and it will run. This is just one more way of starting your Spring Boot application. Okay, so our Spring Boot application has started. And here you can see we have printed out welcome to learning Spring Boot with Samarth, sponsored by Microstream. All right. Now, if you add one more sysout over here, a print statement basically, will it automatically print, or will it, you'll have to manually stop and start the server? Let's say hello world. If I save this file, will it print it here or will it not print? What do you think?
No, it won't print.
Correct, it will not print because this change is not deployed in this embedded Tomcat server. The way you deploy it is you terminate the application and you start your application again. Now it will print because we have terminated and restarted our application. Now you can see it is printing hello world here. Now you can avoid this manual termination and start of your application if you enable or if you add the DevTools dependency here. Let's uncomment this and save this file. Let it build. Let's terminate the application also since we have added a new dependency. Whenever you add a new dependency, always terminate and start your application. Now let's start this application again. Now on application start, it will print these two lines, which is welcome to learning Spring Boot with Samarth, sponsored by Microstream, and hello world. Okay, now if I add another sysout statement, will it automatically print or will it not print? Since I've added DevTools, so what do you think? Let's say if I write here, auto restart me, auto restart application. Okay, now if I write this, you can see this file is not saved here. How do you identify if a file is not saved? If a file is not saved, you'll see this asterisk symbol over here in this tab, the small symbol. So that is how you can identify a file is not saved. Now, if I save this file by pressing Ctrl S, will it print this or will it not print? What do you think? There is a difference. Now I've added the DevTools dependency.
It will print, I think.
Yeah. Why it will print? Because it will auto restart the application for you. Let me save this file. So I'll save this file now. So I've saved this file. Just monitor the logs. You can see the Spring Boot application has got auto restarted. It has got auto restarted, and you can see that it is picking up the latest change also. So it has auto restarted with the latest changes. So this is the advantage of using DevTools. Whenever you save a file, it will auto restart the embedded Tomcat server and it will deploy your change in the embedded Tomcat server. Now, one thing to remember is, as the name mentions, DevTools, so it's a developer tool. So you should not push this dependency in your production server or for your production application. Just take care of this, because although in your running production application, you cannot modify the code, right? You have to add the new jar file and run it there. So it's of no use. So it will be an unnecessary dependency there, although it will not break anything. But just take care, don't add it, because it's an unnecessary dependency. It will just increase your jar file size. Okay. All right. So this is what's the use of DevTools. So does anyone has any doubt about like how you can use DevTools and what exactly it is used for? Is everyone clear? If
Just one question I have. This is Tejas.
Yeah,
So it is mentioning about like restarting the application, entire application, right? By just modifying one line of code in application. So is it possible that I can just deploy this particular Java file or Java class
jar file
in the application?
You want to deploy the artifact of this application to, let's say, AWS cloud, right?
Yeah, I mean, just like a JRable, right? It will just compile one simple file and it will deploy instead of entire.
This is the deployment file, jar file. You deploy this file. Let's say if you want to deploy an AWS EC2, you spin an AWS EC2 machine. Okay, you install Java JDK 8 there, and you basically upload this jar file on S3, which is your block storage, and you make this jar file publicly accessible or just accessible within your EC2 machine by configuring the proper security permissions or policies for your IAM role or whatever. And then in your EC2 machine, you can download this jar file by using wget command. Once you have downloaded, you can run it the same way that I demonstrated by using jar file name command. Okay, so you can run this file. Correct.
Okay. Yeah, is there an alternative to use this DevTools like JRable or something? Can we use that as part of Spring Boot?
Okay, so see, this DevTools is just for your local. It is not helpful for your production deployment or your cloud deployment. Reason being, this is only meant for your local testing and developing of application. For deployment, just remove this and deploy your application, because it's of no use to use. It is not going to help you in any way in your deployment or to automatically deploy onto your production server or to your external server. It's just that it will restart your application, running application in your Eclipse whenever you make any change or in your particular ID.
Okay, thanks. Have you shared this? Yeah, I think that answers my question. Have you shared this particular project to everyone? I missed initial part because of my laptop issue.
So yeah, I'll just share this part. This is the repo. It's a public repo. This is my repository only. I'll share it with you guys. Here you can have all the final projects, although you'll not have the initial projects, like how these projects are getting created. The explanation of step by step is what you'll get in today's session. But here you can just, if you already know Spring Boot and you have basic idea about everything, you can directly also refer these. But I have made a lot of, I've used a lot of cutting edge frameworks. So I think it would be better if you attend the entire session, and then you will understand each and every dependency in each and every line that is in the code, and you can use the same for your office project or your college project and build a very good Spring Boot application, very robust.
Thank you.
All right.
Hello.
Yeah, go ahead.
Yeah. So can we change the embedded Tomcat server to something else?
Yes, you can embed. You can change it if you want to use, let's say, JBoss. In that particular case, what you can do is you can exclude the Tomcat dependency from your web. Okay. So first of all, DevTools I had uncommented, right? Just open this web. Search for Tomcat. So see, this is your Tomcat dependency, or all your Tomcat dependencies are here. You can exclude the Tomcat dependencies from your web dependency and add your JBoss dependency or some other dependency wherever you want to deploy your application. But your Spring Boot application will not automatically start and deploy in it, because it's not created like that. They only support through this web Tomcat server, not other servers.
But this form is as part of jar file, right?
This form
I mean,
is
the
your
Tomcat.
application form file, and this what other form I opened was the effective form of Spring Boot Starter web project. So basically, this is the artifact ID, right, of this dependency. So what we are doing is someone else has created this project, right? The Spring Boot guys, Pivotal guys have created this project, Spring Boot Starter web. We just leverage this in our Spring Boot application, and we build on top of that. So this is their framework. So they are providing this embedded Tomcat server, but
Right.
I
So
think, yeah,
will you please cover by customizing the server to something else so that it will be clear if time permits?
With JBoss server.
No, anything just to know like how can we customize the embedded server to something else.
Okay,
you
actually I've not
mentioned that
done
like
it,
we
but
can
I just
change.
have idea about it. So what I can do is I can just help you with the Stack Overflow page.
Okay.
Like
In general, like different projects may go with different servers, right? So with the Spring Boot with a different server.
I've seen this like some people in some investment banks do this. So they were my students, so I shared this link with them and they could exclude it and add their specific one. See, I showed you the effective form, right? It had these dependencies. So this guy has excluded this dependencies. Now exactly which server he is using, he is not, yeah, okay, he is using that so that we can run on JBoss server. He wants to use JBoss server. So this is a typical use case of a, investment bank or some place where they're using some legacy code and they want to stick to their legacy server. So you can use this page and just follow this documentation what you have here. Okay, this will help you.
Oh, okay. Yeah, thank you. I'll go with that.
Kind of a R&D thing. You'll have to trial and error to make it possible.
Yeah, but in general, right? Like so in general development, the projects go with Tomcat server itself.
That's a choice actually.
Yeah, that's choice,
Every
right?
company
So
has a different choice. In my
yes,
like the
yes, you
companies that I have
recommend.
worked, like Goldman Sachs, Mastercard, State Street Bank, Oracle, they had used this only, like Tomcat server.
Okay.
But I have seen some students, since I've taught thousands and thousands of students. So I've seen like some students like SocGen students, Society General Bank students, or Morgan Stanley students. They generally like prefer some other servers.
Right, like WebLogic also like the popular one, right? Application
Correct.
server. So
Correct.
yeah,
So I'll connect
it's
with you
something.
again,
Yeah,
Shisha, in the break, because I don't want to utilize others' time in this.
sure.
We'll reconnect. You can also add me on LinkedIn. We'll reconnect after the session. If you want any help with this, I'll help you out with that part.
Sure. No problem. We can connect. Yeah. Thank you.
Okay. So let's quickly summarize what we have learned in this session. So in this session, we have learned how we can leverage the power of dev tools and enable rapid application development and enable rapid functionality verification. So as you saw, we could rapidly now develop our application, and as soon as we saved our file, we could rapidly verify that what we have written is correct by adding the correct sysout statements, or you can add log statements. Okay. So that is how you can test your application. All right. So is this clear to everyone? DevTools? I think I've already asked you if it's clear and you have given clear. No, it's for previous one. If it's okay, it's clear, right? All right. So I'll move to the next topic. All right. Now let's understand actuators. So as part of this hands-on, you're going to understand actuators and the actuator health endpoint. First of all, in this hands-on, I'll show you like how you can inject the actuator dependency. Then we'll understand the health endpoint, the basic health endpoint, which is enabled by default. And then we are going to enable the detailed health endpoint which is not enabled by default, then I'll explain you a practical industry scenario where it should be implemented. Okay, let's get started. Let's navigate to our Eclipse IDE. Let's navigate to our POM file. Let me minimize this. So here in the POM file, you can see that we have added the actuator dependency. Now let's open the application.properties file. So this is how you inject the actuator dependency, by adding it in your POM file. So in the dependencies part, you can see I've added this dependency. So these are all the dependencies that we have. Okay, this is the actuator dependency. Now let's navigate to application.property file. Here you place all the configurations for your Spring Boot application. Now that we have added this actuator dependency, and whenever you add the new dependency, it's always recommended that you stop and start your application manually. Don't depend upon dev tools whenever you add a new dependency. And the live reload doesn't really works very well whenever you add a new dependency. Okay, so it's I recommend you, with my experience, that manually start and stop the application whenever you add a new dependency. Okay, before we write any more configuration, before we enable this detailed health endpoint, let me show you what is enabled by default. Always read the logs also, it gives you very good information about your application. So here you can see in your logs, you can see on which PID is your application is running on. You can see the profile. Right now we have not enabled profiling, that's why it says the profile is default. It gives you some suggestions. You can see your application is running on port 8080. You can see it took how much time for your application to start. Then you can see that your H2 is also enabled. So H2 is enabled by default, and you can see your database is available on this. I'll explain you this when we come to the H2 part. Right now, just added the H2 dependency, not configured anything. By default, you get some configurations when you use Spring Boot. That is why we say like you start with something, because you get a base created in Spring Boot, and on top of that, you can build your things. That's the advantage of using Spring Boot. You can see Hibernate, ORM 4 version, everything over here. What we need to focus right now on is this: exposing one endpoint beneath base path actuator. You can copy this part from here, navigate to your browser, type here localhost :8080 / actuator. And this is the response that we are getting. Let me show you this response in a formatted way. So I have added, actually in this one, I think, yeah, in this one. Let me type here localhost :8080. I've added a JSON beautifier. So, okay, it's not working. All right. So this is the response that you're getting. If you're finding this JSON response difficult to read, what you can do is you can copy it, go to your VS Code. I'm showing you step by step the things you need to do to understand and learn and build a strong foundation with Spring Boot framework, so that you can become an API developer, or you can become a microservice developer, or you can even become a microservice cloud engineer tomorrow. Although cloud part we are not covering, but this will give you a strong foundation in the microservice part, and cloud part you can learn and you can deploy your Spring Boot application then. Okay, just paste this part here, this thing that you have copied from browser. Save this file as a JSON file. So let me save it in documents, in Microstream 2022. I'll create a new folder here. Laptop is too slow. Let's name it temp. Open this. I'm going to save it like, let's say, temp.json. Just write .json. File name, you can write anything you like. And select here, either you can select JSON. Since I've given the extension, I want to select all files. Save. Okay, it seems it is not saved. Okay, it's saved. It just took some time to reflect. Now that it's saved, you can see some colors here. And also you can do right click and click on this format document. Now you'll see it in a readable format. So this is much readable, right? The response of actuator endpoint. So this is the response that you have got from your actuator endpoint. The very first thing that you see is the actuator link itself. Then you see is the health path, which is this. So this is like, if you know the other things like what all is in the health endpoint, you can just write / that thing, and you can see the health endpoint actuator health endpoint URL. So you can copy this URL and navigate back to your browser, open a new tab, paste this URL and execute. Here you can see it is giving this response status up. This means our application is up and running. So what's the practical use case of using health endpoint? The practical use case of using health endpoint is that basically when you deploy your application onto, let's say, AWS cloud or any cloud, in that case, if you want to see the status of your application without logging into your application, or if you want a developer team in your company to see the status of your application, what your developer teams can do is they know the base URL of your deployed application. They can just use the actuator endpoint that they have enabled while giving the jar file for deployment to the cloud team, and they can hit this endpoint and they can see that their application is running in a healthy state. Okay, so is this clear, like the practical use case, like when you should use actuator health endpoint?
Yes,
Alright.
Samarth.
Okay, thank you for responding. I would like everyone to participate actively and respond. Take the most out of this opportunity, get your doubts cleared, and learn the most out of today's session. I'm not diving directly into the complex concepts because this is how I've designed the course. I take you from the basic to the advanced so that you learn it in and out. Okay, so this is your basic health endpoint. Now, if you want to enable the detailed health endpoint, how do you enable a detailed health endpoint? Navigate to your application.properties. Here you can see I've added this property here. I'll uncomment this property. So this is a comment. By adding this hash over here, you can write a comment. The comment is configuration of actuator detailed health endpoint, and the property to enable actuator detailed health endpoint is this management.endpoint.health.show details equal to always. Just make a note of this property, or you can always refer this project. You just need to remember what to add and what it will do. So that is why this course is designed in a way that you can directly start creating Spring Boot applications or your college projects, or maybe get a promotion by adding some additional things in your office projects. Okay. So here you can see, just by adding this property, I'm enabling the actuator detailed health endpoint. Again, in the logs, you'll see exposing one endpoint beneath base path actuator. So what is changed now is, if you navigate back to your browser to your health endpoint. So I just closed the health endpoint here, right? No. Okay, let me close this. Let me take you back to that browser. So this is that browser. Let me refresh this health endpoint and you'll see a different response now because we have enabled the detailed health endpoint. As I think some of you are having some internet issues, 4 or 5 of you, because you're getting disconnected and I have to readmit again and again. But don't worry, I'll just keep an eye, and if you get that issue, I'll readmit you in. All right. So here you can see this is the detailed health endpoint response. Now, along with seeing the status of your application, you're also seeing the other components which are part of your application. Since I've added the H2 dependency, and it is basically adding an embedded database, which is H2 database. And because of that embedded database, you can see that our database is also running, and it is in good status. Like the status up means it is up and running. And the database name is H2. Validation query, it's something like we don't need to care about it. And you can see the disk space. You can see the total details of the disk space. I think it's in bytes here. And you can see the ping status. So these are the details that you can see for your application if you enable the detailed health endpoint. And for enabling that, we just added this simple property.
Samarth, I have a question. Like, suppose if you have not added that H2 dependency, then will we see that that status?
No. Let me show you. If you don't have something, why will you see that, right?
Yeah, H2.
If
Yeah.
you add some, let's say, JDBC connection, then you see the JDBC connection, like whether your application is able to connect to that, let's say, Postgres database. Your application is able to connect to the Postgres database or MySQL database or MongoDB.
Yeah.
Let's say I just remove this dependency from here. Although I don't trust DevTools for this, but let's see. Otherwise, we'll manually start and stop the application. So DevTools is not good whenever you are basically restarting your application. So see, it was still showing that H2 because of the DevTools hot restart. Whenever you change a dependency, always manually start and stop the application server. Okay, I think I've added some properties. Okay, yeah, this is because in the main file. Okay, this is because this application is using H2 at everywhere. Like this repositories and everything is trying to access H2. I'll have to comment out everything if I remove H2 dependency.
No. Please don't do that. But I was just want to ask, like,
yeah,
if
you got the point, right? But
yeah.
all right. So, all right. So we have completed this hands-on. Like we have understood how to inject, basically add the dependency in the perm file. We have understood the default health endpoint. Then we have enabled and understood the detailed health endpoint. Then we have also understood the practical industry scenario where it should be implemented. So it should be implemented in a scenario where your application is getting deployed and you want to check the health of your application by using the health endpoint of your deployed application. Because let's say you don't want to give access to your AWS account to your dev team, right? Development team. In that case, they can check your deployed application, the status, the health of your running application by either using health endpoint, or they can log into your running EC2 machine or your server, right? These are the ways that they access.
Sai here. I just have one doubt.
Yeah.
Like you said, this might be useful in the scenario of production where to check whether the application is up or not. But if we expose this endpoint, it is also visible to the end users, right?
Yes,
They
if
can
they access, yes, it is accessible to end users.
And how can we, because if we expose this endpoint, the other information, like it has exposed the information of H2, like application details may be also be exposed.
No, credentials are not exposed here. Only the health.
Yes.
And let's say you don't want to expose this part as well, database name.
Yes.
In that case, you'll have to configure Spring security and you'll have to enable an authentication over this endpoint by adding some authorization. Application level security you'll have to implement.
Yeah, to use this feature in terms of authentication, we need to authenticate it, right?
Correct.
So that it
and not by default, but you'll have to configure Spring security in your Spring Boot application and add authorization and create users. So your admin user will be able to access this, whereas other users won't be able to access this. And you'll have to log in with the admin user to access this, and the other users will have to log in with that other user that you have created to access the other endpoints.
Sure, thanks.
Okay, so let's summarize this. So as part of this hands-on, you have learned how to configure and implement actuator. You've also learned how to access actuator health endpoint and how to enable the actuator detailed health endpoint, and understood where and when it should be used in enterprise applications. So if everyone is clear with this hands-on, you can write clear in the chat and we'll move to the next hands-on.
Yes, so much clear.
All right. All right, let's start with this hands-on. So you have learned in the previous hands-on about actuator health endpoint and detailed health endpoint. As part of this hands-on, you're going to understand or learn about actuator info endpoint. So as part of this hands-on, I'm going to explain you actuator info endpoint, and by default, actuator info, by default, actuator info endpoint is disabled, or we can say it is hidden. So we are going to enable the actuator hidden endpoint, the actuator hidden info endpoint. And after enabling the actuator hidden info endpoint, I'm going to show you like how you can basically add some information about your application and read that information by accessing the info endpoint. Okay. And I'm also going to explain you a practical industry scenario where it should be implemented. After demonstrating what is info endpoint, I'll tell you a practical industry scenario where it should be implemented. Because once you'll see something, you'll understand it better. That's the best way of explaining, right? To demonstrate the thing, you'll see it like. All right, let's go back to our Eclipse. Let's go back to our application.properties. So in order to enable the actuator info endpoint, we need to add these properties. I'm just copying and pasting these properties here. I'm going to uncomment, make some modifications. All right, in order to enable info endpoint, just write here management.endpoints.web.exposure.include equal to the endpoints you want to enable. So health is, I know, by default enabled, but if you write this property, whatever endpoint names you'll write here, only that will be enabled, whereas rest of the endpoints become disabled. So because of that, I wanted to keep my health endpoint. That's why I've written here health. And I also want to enable the hidden endpoint, which is info. So I'm writing here info. So this will enable the health and info endpoints. And along with this, for info endpoint to be enabled, we also need to add this new property. So this property was not required in the previous versions of Spring Boot framework, but from the latest versions, or this is like nearly the latest version, which is 2.5.6. You need to add this property. You need to add this property management.info.environment.enable equal to true. Then only it will enable your info endpoint. So this is how you enable the info endpoint. Now that we have enabled the info endpoint, let's start the application and let's see the kind of a response we get from the info endpoint. Although we have not configured the info endpoint, we have just enabled the info endpoint. So we'll see an empty response. But I want to see, I want to show you that how you can access the info endpoint and like it is enabled. I want to demonstrate like it is enabled right now. Then I'll demonstrate how you can configure the info endpoint. All right, so our Spring Boot application has started. Let's go back here. Let's navigate back to the actuator base endpoint. So this is the actuator base endpoint. Here you can see all the endpoints. So now you can see I'm seeing it in a formatted way. I think my JSON beautifier was not working before. Okay, so these are the endpoints which are enabled in actuator. We have the health endpoint, detailed health endpoint basically right now. And if you want to see a specific part of the detailed health endpoint, you can just append that property here. Let me show you this part. I think this was missed, right? Copy something like, go here, replace the last part with DB. And you'll see only the DB part. So this is how you can use this part, health path. And let's focus on the info endpoint now. So here you can see as a response of info endpoint, I'm just getting an empty response. Can anyone tell me why am I getting an empty response?
We have not configured it, I think.
Correct. So we have just enabled the info endpoint. We have not yet configured the info endpoint. Let's configure the info endpoint. In order to configure the info endpoint, I'm going to uncomment these properties that I've added here. I'm going to add certain information to this application. The first information is info.project.name, and the project name is Bookstore Design, info.project.team, and the team is Microstream, and info.project.instructor is my name, info.project.environment So I'm writing here local because it's a local property file. We have not yet enabled or learned about profiling. All right. So I've added these things and DevTools has restarted the application for us as soon as I saved this file. Let's go back to the browser. Let's refresh this page now. As soon as I've refreshed this page, you can see I'm getting this response here. So this is how the info endpoint works. Whenever you write info dot project, so it is like this. And if you write dot name, dot team, dot instructor, dot environment, it comes like this. So this is how the info endpoint can be configured to send particular kind of information. In which kind of a scenarios, practical industry scenario where you should use info endpoint is, let's say if you're working in a MNC where there are multiple teams creating multiple microservices, and let's say you are accessing someone else microservice by their endpoint, and you just forgot like what's the team name who's handling that microservice. So instead of going and asking your manager if your company developers have enabled the info endpoint, each and every other developer in other team can hit this info endpoint and get the team name or maybe the person name managing this application and reach out to them and solve their issue related to that particular API. So is this clear to everyone?
Yes, Samarth, clear.
All right. Let's quickly summarize what you have learned in this hands-on. So in this hands-on, you have learned about how to enable hidden actuator info endpoint, then how to configure and implement actuator info endpoint. Then you have also learned about how to access actuator info endpoint and understood where and when it should be used in enterprise applications. All right. Before we go to this one, we'll take a quick break of 10 minutes. If you have any questions, you can ask. We'll take a 10 minutes break.
Just one question, Samarth. I'm trying to actually try this test this particular what you can say this
Project.
dev tools in my
Okay.
local.
Okay.
I have imported your project, the Spring Boot bookstore design application, and
Yeah.
I have added the system.print like out.println statement in the run method.
Yeah.
I'm running the application, but it is still not giving me the message automatically.
Okay. Let me see your name here, Tejas, right? And
Yeah.
let me
Do you
give
have
you
the-
share
sorry.
screen access.
Do you have the automatic building enabled? Like it builds automatically and save.
You go ahead.
I'm already unable, like running the application. The application is running. I just added the statement in the run method, and it should populate right in the console automatically.
One minute, just let me answer one more question. What we can do is you can share your screen. I just help you sort it out.
Sure, sure. Yeah. Just
Let me give you access to share screen. Yeah, you can share your screen. Don't forget to unshare once you're done. Only one participant can enable sharing.
so yeah, this is the statement I have added.
One
Okay,
minute, it's loading. Yeah, it's loaded.
okay. So I'm using IntelliJ. So this is the application, and I have added this line. Okay, and I'm not getting any. So this is the test one which I got initially when I run the application. After that, it is not giving me this message.
You have some issues also. It is red on the right side, Maven tab. Your dependencies are not properly resolved, it seems. Did you manually stop and start the server after adding the DevTools dependency?
I actually tried multiple things. I tried to run the command, my one clean install here. I also tried running application directly from here. So
Stop the application first.
okay.
Yeah, select clean, press command. Okay, it's Windows, right? Okay, press control, clean, install, select install also.
Okay.
Press control, hold control. Now click on that green icon, a green button, play button. It will do both of the things together.
And this is the application properties file. I have disabled the prod here as you suggested. And this is the only thing which I enabled.
Yeah. Okay, open the POM file. Show me the POM file.
It has DevTools.
Okay. Okay. Now try to start the application and then again say, actually here it's auto save. Now that can be a problem with DevTools and IntelliJ. In IntelliJ, you don't have to save a file, right? As soon as you write, it's getting saved. The file is getting saved. So with every word you're typing, it is getting saved.
Okay. Even
That can be, yeah, you're getting my point, right?
Yeah.
See, you don't have to save a file here. I think this is the issue why DevTools is not working with IntelliJ.
Okay. Okay. I will try then later on with the Eclipse and let you know if there is any problem tomorrow.
Yeah, it works. Yeah.
So I can run the application directly from here, right? After building, or do I need to deploy also?
No, you don't need to deploy. You don't even need to build the application for running that. That clean and install part we did is for if there is any dependency which has not got installed or properly not installed, or there is some other conflict of dependency. For that, I made you do that.
Okay. But still, it is giving me red here.
It's saying unresolved dependency Spring Boot Maven plugin 2.5.6. Maven plugins. You can just Google out this. There's some plugin related issue with the IntelliJ because you have imported a Eclipse project. Did you delete that dot setting folder and all that is specific to IntelliJ? Why? Not now. Before importing the project, just go to the project folder if you want to import Eclipse project into IntelliJ project. You need to delete the you need to delete. Okay, I don't see that. Can you? Okay, you have dot idea. You don't have that dot setting. Okay. IMPL is also related to that. Okay. Just go back here. Can you view the hidden files in this folder? if it is hidden. Okay, it's not even hidden. So it's a different issue. I think you can just Google out that plugin issue.
Sure. Yeah. I will stop sharing.
Yeah, no issues.
Thank you.
Yeah. Spring Boot fundamental. Just one moment, guys. Spring Boot fundamental. Okay, let's continue. I start sharing my screen. You can view the screen too, right?
Yes, we can see.
The time counter or the Git repo?
Time counter.
All right, so it's screen too. All right. So as part of this hands-on, I'm going to teach you like how to enable actuator matrices endpoint and how to use actuator matrices endpoint. So let's get started. We'll go to Eclipse. Here also let's write here comma matrices. So it's the same thing what is written above. I'll just remove it. So we have enabled 3 endpoints now, along with health and info. We have also enabled the matrices endpoint. I hope there is some improvement in the audio quality. I've connected my mic now.
Yeah, it's good actually.
All right. We have enabled the matrices endpoint and actuate. DevTools has restarted the application for us. Now let's go back here. Let's go to the base actuator endpoint. Let's refresh this page. And here you can see we have the matrices endpoint. I'm just opening this matrices endpoint in a new tab. So this is the response that we get from the matrices endpoint. Now, if you want to see the specific things like how many active connections are there with the database, you can just copy this, add a / here, paste it, and hit it. Here you can see the active connections. So currently I don't have any active connections, so the value is 0. Similarly, if you want to see, let's say how many threads, how many daemon threads you have in this application, like basically you can see your thread dump. So you can see that we have 13 daemon threads in this application, low priority threads. Then if you want to see JVM memory, what's the maximum memory that you have? So you can again, so this is how basically you can monitor different matrices of your application. So you just need to write your / and paste that parameter from there. You can see the different memories that we have: compress, class space, PS old gen, PS survivor space, meta space, PS hidden space, code cache space, and values like we have this heap, non-heap. So you can monitor these different matrices. You can monitor your heap dump. You can monitor your thread dump by using this. I think you can also download your thread dump from here. Let me see which one it is. You can see your live threads, peak threads, thread states. If your application is in blocked state because of some like synchronization problem, you can just use this and monitor which thread it is which is causing that problem. That's why you should always give thread names if you're having a multi-threaded program. It might be some other actuator endpoint, not this point. So you can also download your thread dump or your heap dump by using actuators and then upload it into some analyzer tool, which are generally paid tools, and analyze your thread dumps and heap dumps. That things you have to do sometimes. Okay. Please, there is a question, sir. Please be sure to share the recorded video if I'm not there in the session due to power cut. Chandra Rakesh, the recording will not be with me. It will be with the Microstream guys, and they will send you the recording. So generally, I don't receive the recording link. Students receive the recording link. So don't worry, you can just follow up with a mail, the mail which you have received for the invitation, like with the same mail ID, just follow up with them if you don't receive the recording, or you can reach out to me on LinkedIn. If you have not received the recording, I'll follow up with the Microstream guys after the session. Okay. Generally, it's not, you will not receive it instantly. You might receive it in a week or 2 weeks. But if you don't, you can just follow up with them. And if they don't respond, you can ask me to follow up with them. I'll get you the recordings. Okay, so this is how you use the matrices endpoint. I think this we don't need to summarize. This is pretty clear, right? Has everyone understood the matrices endpoint?
Yeah.
Yeah.
All right. Now let me show you how you can change the base URL of actuator to a custom URL. Okay. So this was your base actuator URL, localhost 8080/actuator. Now, if you want to change it to a custom URL, you can do that with help of this property, management.endpoints.web.base path app check. I would also recommend when you're using DevTools, it can happen that some of the configuration changes are not picked up by the DevTools. In that kind of a scenarios, you can manually stop and start the application. But generally, your code changes are always picked up by the DevTools. That issue will not happen, but this issue can happen. And whenever you add or remove a new dependency, always manually stop and start the server. Don't depend on DevTools. It will not catch that change. Now that we have added this new property here, which is management.endpoints.web.base path equal to /app/check. This will change the base path of the actuator. Before going to browser, if you want to confirm this change has happened from the logs, you can just check like exposed endpoints. So you can see exposing 3 endpoints beneath base path /app/check. This means actuator base endpoint has changed. So let's copy this. Let's go to the browser. Now this actuator endpoint will not work because we have changed this actuator endpoint. Here you can see it says 404 not found because we have changed it to this URL. So we have changed the base endpoint, which is /actuator, to now become app/check. So this is how you can check your, basically now you can see all the sub endpoints have also changed. Okay, so we have changed the base endpoint and all the sub endpoints have also changed. Like for health also we have app/check/health. For info also like similar /app/check/info, and same for matrices. So all the base endpoint, when you change the base endpoint URL, all the sub endpoint URL also changes. Okay, so let's summarize. As part of this hands-on, we have changed the actuator base URL, which is this, to a custom URL like this. Is it clear what we have done as part of this hands-on?
Yes, Samarth, clear.
All right.
Yes, Samarth.
All right. Just give me a moment. We'll have a lunch break, guys. What time do you want lunch break on? Because I see people from all around the globe has joined today's session. So like everyone can just write by what time they would like a lunch break. I mean, according to IST timing. Just suggest a lunch time in the chat. I'll just have a look at everyone's chat. This is IST timing, okay, guys? Students from other countries, please use the IST timing for providing a lunch time that you would like. Okay,
Hi,
so
I have one question. How long it would be? I mean, how many hours of this session going on?
This session is scheduled from 9 a.m. to 4 p.m. and we have a 1 hour lunch break in between and some small breaks in between for water and all.
Oh, okay. But because here we are like midnight in USA, so I'm asking.
Yeah, I understand.
Okay.
This year, I think US batches will be scheduled for October. But yeah, what you can do is you can sit today and you can practice whatever you have learned. And in October batch, it will be during your day. So you can again sit and ask your doubts and clear your doubts. Or maybe, you can just learn some new concepts in that batch.
Yeah, thank you. Yeah, and one more question, like it's a 2-day session, right?
Yeah. So today we are covering the fundamentals and tomorrow we are going to cover the advanced concepts.
Okay. And can you just give me like how many hours remaining so that I can calculate?
Yeah, sure. So approximately 4 hours are remaining, which is inclusive of 1 hour lunch break.
Oh, okay. Thank you so much. Yeah.
All right. So some people are saying 12, some are saying 2 p.m. will be too late. I'll also feel hungry by then after speaking so much. Uh, so I think 12:30 is the middle time for everyone. So I think 12:30 is the middle of what everyone is saying. So we'll keep a lunch break around from 12:30 to 1:30.
Yeah, that would be good.
All right, I'll just write here. Just remind me at 12:30, guys. If I forget and continue with the session, we'll just end the current hands-on that will be on and we'll have a lunch break then. Okay, let's move to module 4, profiling. This is a very important module. Whether you're working in microservices or overall, this is a very important module because you need to profile in your company in order to segregate your environment specific properties. Even in Kubernetes, I mean, if you're using some CD tool like Argo CD or something, there also you need to profile by different Git branches. Here in this microservice application, we are going to profile by adding different configurations in different property files. Okay, before we begin, I know that majority of you must be knowing this, like different deployment environments in IT industry. But since this batch is also for some students who are in college right now who don't have industry exposure, so I've included this basic one topic over here. Different deployment environments in IT industry. So what are the different environments? I know there are different environments in different company, but I've just mentioned the generic ones. First is the development environment. This is where application development tasks such as architecting, coding, and debugging takes place. So here is where the developer develops the code, and then is the test environment. This is where application testing is done to find and fix errors and to ensure that application meets the business functional requirements, just to ensure that developer has developed what the business guys are expecting. This is why the test environment is kept so that a final business testing can be done. Whether if we have asked a developer to build A and if he has built a small a or a capital A, what exactly has he built it to understand that? Then is the staging environment. In some companies, in product companies, there is a staging, and generally service-based companies, they have a UAT environment. It's the same thing, a final testing before it goes to production. So this is where the final testing is done before the application is deployed in the production environment, because this environment is a production-like environment. Then we have production environment. This is the last environment where new business functionalities are deployed for the end users. So in your production environment, whatever you deployed is accessible to your clients or to your customers. So let's quickly summarize what we have learned as part of this theoretical topic. In this topic, you have learned about the different deployment environments in IT industry. Now let's start with the hands-on. Before we start with the hands-on, if there are any students, college students who want to understand any specific thing from here, you can ask your doubt.
Yeah, Samarth, actually, many company I have listened like only 3 environment: dev, test, and prod. So that staging environment, what is that?
Exactly, it's like your UAT only. Before, after testing, there is one more like staging environment in which you put and the business owners and test your application to see whether it's exactly as what business requires. Just another kind of a test environment where a business minded person or a business owner of the application, product owner, does the final testing, because in the end he has to take the blame if it's not according to customer or client thing, right?
Okay. So like environment is decided by that particular company. Am I right?
Yeah, it's company
Like-
specifics.
Yeah, okay.
Yeah, some companies have multiple staging environments. Like in my last company in Here Technologies, they were like staging 1, staging 2 environment. There was a separate testing environments like SID testing, then I think CIT testing, multiple test environments were there. Although we used to deploy the production application from any environment, like for a particular customer, which was a different thing, let it be. But it's just company specific. I mean, the general thing is to have development, testing, and production. And before
Production,
testing,
yeah,
yeah,
yes.
before production, if you want to test something in a production like environment, you can use staging. Now what is a production like environment is, let's say in your development environment, let's say if you are deploying your application, or let's think at a bigger level, okay, at an architect level now, not at application developer level. Now let's say in your development environment, you want to deploy you want to spin an EKS cluster on AWS. You understand, right? EKS, Kubernetes cluster.
Yeah, in the AWS, yeah.
Yeah. So let's say in development environment, you will spin with 2 nodes and with small size nodes, like let's say T3.micro nodes or medium nodes. But in production, you want to deploy in a huge, you want to have 10 nodes and scalable up to hundreds of nodes to, load balance your customer traffic. In that kind of a scenario, in dev environment, the developer will do his testing on the normal 2 nodes. And then in test environment, again, he'll do the testing on, let's say 2 nodes or maybe few more nodes. Then in staging environment, which is your production like environment, you'll have the same kind of environment which is in production. So you'll configure like EKS cluster with 10 nodes and big machines sizes for your nodes. Basically, your nodes are just EC2 machines. So, or maybe spot or on-demand instances. You'll just run a big machine and deploy your application and see the performance there, just to see like how exactly will the performance be in production by adding artificial load, by doing load testing or scalability testing, all those testing before it goes to production. So that's the final thing.
Suppose it fail in that, then what will happen?
In staging environment, if it fails, then you'll check your configuration to see whether the nodes are not enough. So you'll increase the nodes.
Okay.
Yeah, that all things you'll do.
Okay. I understood. Thank you.
All right. So now let's move to this. Okay, so everyone is clear with this environment part, right? If you want to understand with a different example, I can give you 10 different kind of examples. If everyone is clear, you can write clear in the chat. I'll go to profiling topic then. All right. Let's move to profiling. So what is profiling? Implementing dev, test, UAT, and prod environment profiles, understanding configuration required to change port number, and understanding configuration required to set active profiles. You'll see these things in action. So basically, what is profiling? So basically, profiling is something which enables you to separate the cross-cutting concern logic of externalizing configuration into environment-specific property files. Okay, so this means what? A very simple example that we are going to implement is, we're going to create these different property files. Right now we have this, let's imagine we have only this application.property file. Let's say you have created this application. Now you have created this application dash dev property file, application dash prod property file, application dash test property file, and application dash UAT property file. So for your different environments, you have created different property files. So your application.property file is for your local, and for your, let's say, dev environment, you're going to use this property file and you're going to deploy your application jar. So what you're going to do is you're going to create this file, and I'm going to show you, don't worry. Just now, right now, understand there is just different property files for different environments, and this is only called profiling. Don't go with the fancy words, cross-cutting concern and all. Cross-cutting concern basically means you have, let's say for your dev, you'll have a different database. For your production, you'll have a different database. For your test environment, you'll have a different database, right? So if you place everything in same file, you'll have to comment, uncomment, and deploy your application, right? While deploying to specific environments. In order to avoid that, we enable this profiling. We place the dev specific environment database configuration in dev property For production deployment, we place the production deployment properties in production, this application.property file, which is this application-prod property file. And similarly for test and UAT. So now you understand the basic, like why we need profiling. If you won't have profiling, you'll have to add, let's say, this database for H2. You'll have to copy this and you'll have to add it here. Like right now we have this for, let's say, for local, right? Similarly, you'll have to add for UAT and you'll have to add for prod, and for while deploying UAT, you'll comment that, uncomment this. So all those commenting, uncommenting things you'll have to do and then build your application and deploy. So that's a pain, right? In order to avoid that pain, Pivotal guys have enabled profiling in Spring Boot application. Now, because of this profiling, you're placing your environment specific properties in your environment specific property files. Your dev database configuration is placed in your dev property file. Your production specific configuration is placed in your production configuration file, and same goes for test and UAT environment. Okay, so now that you understand exactly what is profiling at a practical level, let's quickly summarize this video, then we'll do the practicals. So in this video, you have learned how you can configure different environment configurations. Okay, we have not, so as part of this, it's a hands-on, this part. So you have understood what is profiling. In order to implement these profiles, what I'm going to do right now is I'm going to configure the different port numbers and set an active profile and show you how you can set an active profile. So don't worry, just let's focus here. You'll understand what these profiling are. So let's imagine right now.
I have a question, Samarth.
Go ahead.
Yeah, so like how Eclipse will recognize that which properties file have to run? Like there are 4 to 5 properties.
That is what I'm going to demonstrate now.
Okay.
All right. So this is your, let me close. There are too many tabs which will confuse you. So let's imagine we have this application.property file. And this, what you see here, you have not added any server.port here, right? So your application will basically run on application port, Tomcat port 8080. So our application is running on port 8080. Now let's imagine we create these property files. So let's say first we created this dev property file and we have added this server.port 8081. Okay. Now on application start, you want to start your application and you want to load all the properties which are in your application-dev property file. How will you do that? In order to do that, you have to use this command, which is you have to use this property, which is spring.profiles.active, and write here dev. What this will do is it will set your active profile as dev profile. Okay, so this will set your active profile as dev profile. Now, if you see actuator, let's see if actuator is catching this. Okay, so actuator has catched this change, and we can see Tomcat started on port 8081. So can you tell me, like, from where is it picking up this property now? Is it picking up from application.property, or is it picking the properties from application-dev properties?
It is picking from dev, I think, because there is server 8080.
Correct. Let's try to move this over here and let's see what happens. Because before moving it here, we saw that I read in the logs that it was saying exposing 3 endpoints. That means it was picking these properties and then picking rest of the properties from dev. Okay, it is still picking these properties. That means whatever you add in your application.property file, that are the common properties for all your environments. Okay, that is the common property for all your environments. Although it would give, if you have repeated these properties in your another property file, then it would give preference to that other environment which you have set, the active environment which you have set. Let's say we have set the active environment as dev. In this kind of a scenario, it will give preference to the properties, same properties which are in dev. So it will override the properties which are written here by the same properties which are written in your application-dev.properties file. Is it clear, like what it will do? For
like
example,
it will give preference to dev property. You want to say like that?
Let me show you this. In application.properties, if you write this port 8080,
okay,
and if you write here 8081, it will override the server.port and it should start on port 8081. See, it's starting on port 8081. So you see,
Yeah,
it is overriding the property from your default. This is called your default property file with your active set profile property file. This is your active profile, right? Dev.
yeah, yes.
So this is how it is done. Now, if you want to deploy your application
So,
to a dev server,
a question, sorry to interrupt you.
no problem.
So in this case, the naming conventions are like compulsory, right? Application hyphen dev. It
Correct,
must be
correct.
hyphen
Yes.
dev. I can't
It
give
should be
dev
there.
one or something like that, right?
No, dev one can be there, but this application word is necessary and dash is necessary, and then whatever environment name you want to give. If you want to have 10 environments for dev, you can say dev 1, dev 2, dev 3, dev 4, dev 5, and you can like create 10 different dev profiles.
So prefix is like application hyphen, that is mandatory, and after that we can give
Correct. Anything.
any name, and whatever we give here, that has to be the same name in active profile.
Correct. Let me show you this. Like if you want to create, let's say Siri, okay, Siri.properties. I'm just taking the first few letters of your name. Now here I want to start Siri a profile on port 8082. Now here I'll write Siri and save this. Now let DevTools restart.
So
Here you can
this
see
profiles, active profile setting in the application properties, default properties.
correct. Yes. So this active profile setting has to be done in the default properties, which is nothing but this application.property file.
So application.properties file is compulsory then.
Correct.
And whatever we configure in application.properties can be same in the application Siri properties, or can have additional properties too.
No, you can have the same properties as well as the additional properties. For the same properties, it will override the same properties from your Siri property to your local properties. It will give preference to what properties are in your Siri or in your dev over the properties over which are over here. So the same properties which are over here.
Okay, got it. Thank you so much. Yeah.
Some of the best practice, like do we need to have this Spring Profiles active line at the end of the application properties file, or it can be anywhere in that?
It can be anywhere actually. I just added it in the end, but it can be anywhere.
So it will override all the properties irrespective of the position.
Yeah, it will override because after loading it starts the application, right? So it will correct everything and then start the application. So if it has loaded these properties and if it finds okay the same properties with different values, so this is called a property, right? And what you see on the right side is called the value. If it finds the same properties are in the dev profile with a different value, it will override these properties with the dev values and it will start your application.
And if the properties are not present, property is not present,
then it will refer from here.
Okay.
That is how it is. But these properties are common properties for your all profiles, but these can be overridden if you mention the same property in your other profile.
So where can we find all these properties, like predefined properties, which we need to use?
That is where I'm teaching here in the course, right?
Okay,
I mean, you can read from the Spring pivotal page, the official Spring documentation, or you can also like there you'll find it difficult because such a good explanation you'll not get anywhere. That is where you need training in Spring Boot to understand each and everything. And I had learned these individual small parts in my office work over the years.
Okay, yeah, thank you.
Samarth, it's like adding these properties according to our requirement, right?
Yes,
these
yes,
are not
exactly.
mandatory ones.
No, not mandatory. If you want to enable actuator and have configure actuator, so this is how you add. But if you want to have profiling, then you enable profiling. So profiling comes by default. You don't have to add any additional dependency for that. It comes with your Spring Boot. So you just need to set an active profile and create profiles like this, the files like this.
Yeah, here what I saw is mandatory one like a server port. That is the one thing.
It is not mandatory. If you don't write this, okay,
default.
you don't write this, but it will run the default port, which is which port? It is this only 8080. That's the default port for your application. Yeah. But right now it will start on 8081 because we have set the active profile as dev.
Yeah.
If we remove this, it will start again on 8080.
Yeah.
Samarth, Sai here. I have one question. As per the discussion earlier, you have just conveyed the convention of the property file like application dash and environment name dot properties.
Correct.
And this means that we can only use one property file per environment, or we can use multiple property
We
files.
can use multiple. There is an include command also. Let me show you. It must be in one of my GitHub repository. 1 minute. Let me search. I think I've added that also. Like how you can include properties from multiple files, right? Last year, actually, it was a 4-day training. This year, it is a 2-day training. So I had covered a lot more things last year. Or you can just search like include properties from multiple files in Spring Boot. So let me give you the exact thing what you need, because you can place your database properties in different files also. It is something like spring.profiles.include. It is like that, the property name, but I don't remember the exact name from the search.
Yeah, I got it. We are just saying like we can include one property in same this application of properties to include that. And other doubt is like to be very specific to the environment. Is there any keyword like here we are using application dash dev? Dev is the keyword that is relating to environment.
Correct.
So same what you can say same thing will be applicable for the other file as well, right?
Yeah. For prod, you'll write like dash prod, for dash this. Like, let me just give you the exact one. If you have found what is that, is it that only what I'm thinking? Spring.profiles.include. I think I remember that command. It's in one of my Git repo, but right now I don't remember exactly which repo. Like multiple, there are hundreds of repos which I've coded.
Okay, no problem. We can figure out it later. That's not an issue. I just want to know it is possible or not. I can figure it.
It is possible. I've done it.
Yeah. Thanks.
I think it is spring.profiles.include property to, and then you write dev comma prod to have two properties merged together. Like, it is not for the profiling purpose. It is like if you want to separate out your cross-cutting concerns. Let's say you have connected to your Oracle, to your Postgres database and to your MySQL database, both from the same application. You want to place your Postgres properties. So you'll create application dash Postgres.properties and you'll create application dash MySQL.properties. Okay. And in your dev properties, if you want to have both the databases, so you'll write your spring.profiles.include Postgres, comma MySQL, and it will import the properties for both the databases. Getting the point?
Yes.
Actually, for databases, it might override the values. For configuring two different databases is a different concept and a different kind of a code which is required. I think someone has given that. Okay, it is spring.profiles.include. That is correct. It is something like this only. So you'll have to Google out, Ritu, to find that exact. What I remember is it might not even Google out, just go through my Git repository. In one of my Git repositories, you might find it, because I had written this part somewhere down the line. So it might be in one of my Git repos, not this.
Yeah, no issues, Samarth. Thanks.
Exactly. Yeah. All right. So we'll move to the next part. So are you clear like what is profiling, how you can implement different environment profiles and the configuration which is required to change port number, and how you can set an active profile? Is it clear?
Yes, Samarth.
Okay, so one question. If you want to set the active profile now, Okay, let's say I've set the active profile to dev. If you want to set the active profile to UAT, what will you write here?
If
Equal to
we can write
UAT.
that, yeah, equal to UAT.
Correct. We'll write here equal to UAT. Let me see if I added anything. Okay, it will run on default port. Let me make this port 8083. So now that we have set the active profile as UAT, our application will start on the UAT port number, which is 8083. Okay, so this is done. So you have learned like how you can configure different environment specific properties in property files by using profiling, how you can set the active profile by using this property spring.profiles.active. Also, I think the property spring.profiles.include only. You can just Google out this thing only. I think spring.profiles.include. Yeah. Yeah, see, this is the property. To add property from two property files. So he had created two property files, application-4.properties, application-4-override.properties. And he's also putting a limit like max properties can be 33. This is something additional which we don't need to care about. So I'll just add this page only directly to the Zoom channel. Okay.
Yes, yes.
Yeah. Because this is not a thing that you'll generally have to do. This is a very rare scenario where you choose to implement this kind of a thing in your application. Generally, people do is profiling, but sometimes if you want to separate the cross-cutting concern logics into different file, you go with this approach. Okay.
There is some annotation also, right? At the rate profile. So can you use that?
Yeah, that is a @configure profile or some configuration properties where you set the profile from where you want to import the properties and map it to your class that you have annotated that class with. That's
when we work with the Java based annotation.
Yeah. That is you can do in Spring Boot also, but you don't need to do that because there's much simpler way, right? From here you can read and you can directly import a property also by using @value. You'll see that in I think this one cloud module tomorrow. I'll show that part how you can do it. Okay, coming to this hands-on, this we have already done. Best resolution for port already in use problem. So we saw that netstat command, right? You remember this command, netstat command, to find and terminate the port, free the port by killing the process. This is this hands-on all about. Now comes the module design. Before we go to module design, do you guys need a small break?
No, I think 12:30 will be break, so I think we can carry on.
12:30 is a lunch break.
Yeah.
Right now, let's do this module, then we'll take a 3 or 5 minutes small break. Okay, coming to this hands-on, model design, package naming convention, and component scan. So as part of this hands-on, you're going to understand the convention which has to be followed while creating a new package name. I think I've talked about the convention in the first topic itself, right? The convention for the packaging, package naming is you have to write the base package dot your package name. So this is the base package. I've written .config for creating a config package, .controller for creating a controller package, and similar for entity exceptions and for all other packages in this application. So that's the naming convention which you have to follow while creating a new package. Now let's understand what is component scan and how it works. So component scan is nothing. It basically starts searching for your classes to load these classes as beans in the Spring container, and it starts the scan or the search from this base package. And from the base package, it searches all your sub packages. So it doesn't go above this. If you have some other package like com.a.microstream, it will not start the search from there. If your base package is com.microstream, it will start the search from this package itself. So that is why here you have to ensure that you provide the correct group ID, because from this group ID it starts the component scan. So this group ID and this base package name is same. So this will by default be taken care when you generate a skeleton Spring Boot project by using Spring Initializer. Okay, now let's create a Microstream class. So we are just creating a Pojo class here, and the name will be Microstream, and implement the concept of encapsulation in it. And for creating the Pojo, like the normal things we need for a Pojo class, getter, setter, two strings, equals, hash code, and everything, we're going to use the Eclipse IDE shortcut for that. Let's close these files. So in order to create a new package, first of all, you should ensure that you use this kind of a naming convention, base package.model, and you can create this class Microstream class. Let's say this Microstream class, let me remove all these things. This Microstream class has these fields: course name, course type, and instructor name. Okay, and let me remove these things also for now. All right, so you have these three things, these three fields. Now in order to generate the getter setters for this, you can do a right click and go to refactor source. You go to source, generate getters and setters, select all your fields and click on generate. It will generate the getters and setters for this class. Now if you want to generate a constructor, right click, source, click generate constructor using fields, click generate. Now if you want to create a default constructor, right click, again source, generate constructor using fields, deselect like all the fields and generate. It will generate the default constructor. Now if you want to generate equals and override equals and hash code, just right click, again source, generate hash code and equals for all your fields and click on generate. It has generated everything we need. Now if you want to format this file, press Ctrl A and press Ctrl Shift F. On your Mac, you can press instead of Control Command key, and it will automatically format the file. If you want to remove some unused import, you can use the shortcut Ctrl Shift O. It will optimize and remove the unused imports. These are the shortcuts which you can use to quickly code and write your application. You see how much part we have done with the automatic, like automatically how much we have covered. Instead of typing so much, we saved a lot of time, right?
Yeah.
So remember these shortcuts, make a note of it, and do use it in your daily basis. Okay, so all right, so we have created this class, we have implemented the concept of encapsulation. How have we implemented encapsulation? Is like we have private fields and public getter setters. So this variables cannot be directly accessed by like class object reference dot variable field, because it's private, so it can be accessed only through getter setters. So this is how we have implemented the concept of encapsulation. Then we have generated everything we need with help of Eclipse IDE. So let's quickly summarize. As part of this hands-on, you have learned how to name your packages in Spring Boot application. You've also understood how components can work. And because you have understood how components can work, so do follow the convention of naming the packages. Otherwise, your classes will not get loaded and you will be scratching your head. You have also designed our model class, and along the way, like we have designed our model class, right, Microstream, and along the way learned Eclipse IDE shortcuts for generating all our Pojo methods. So you know that right click shortcut, also the same thing can be done with Alt Shift S, and you can select from here. Like instead of doing right click and reaching to this source, you see Alt Shift S is the shortcut for this. So there are multiple shortcuts which you can leverage and code very fast. Okay, so this is done. Before we move to this, let's take a quick water break of 5 minutes.
Yeah, Samarth, I'm able to run this DevTools with the Eclipse properly.
Okay. So with Eclipse or IntelliJ?
Eclipse. IntelliJ I stopped.
In IntelliJ, there must be some plugin. Just Google, you'll get it on Stack Overflow. But although in IntelliJ, I think it might give problem because in IntelliJ, you'll have to disable, I think, the autosave option, I think.
Yeah,
in IntelliJ, files get automatically saved, right? As soon as you type.
yeah. I can see it is running only on HTTP port, not on HTTPS.
I'll be back in just 3 minutes by the break ends. Just give me 3 minutes. I'll be back. All right. Break is over. I hope everyone is back. We'll begin with this hands-on test. Okay, someone was asking some question in the break, I remember.
Yes, yes. So actually, I can see all these endpoints are running on HTTP port instead of HTTPS. So are we going to cover that HTTPS port in next
No,
session?
we are not covering that, but I'll give you how you can enable HTTPS. Although you need a SSL certificate for that. So you can locally generate a SSL certificate and do that. So I think it's not in today's training, but I'll just give you a repo. Last year I had covered that. So, Spring Boot. And I think I have covered it in batch 2 then. SP. Last year actually this training was for 4 days. No? That's why. Okay, let me go to GL, SP. I think in remaining topics. Remaining topics, 13 session. GL. You have to generate and add SSL certificate. I've added the commands also. I think key store demo. No, this is a key store. This is not it. This is Java 1. Enable HTTPS. You'll just have to search in my repo, like HTTP or something. In one of the sub repo, it is not even in that. Here it is. Here.
Okay.
Here it is. Actually, if I add individual projects, it would fill my entire Git repo with projects and projects. That's why I've bulk added the projects.
Okay. Thank you.
All right. So, all right. I think some guys had network issue. They have dropped 2 guys. All right, let's continue with this test model design with command line runner. So in this session, you'll learn about what is command line runner, how does command line runner works, and when to use command line runner. And we are going to test our design, the Microstream Pojo design with command line runner. All right. So this is our Microstream Pojo class design. It has these fields: course name, course type, instructor name. Let's create an object of this and test this class. So here you can see, in order to implement command line runner is an interface. You simply implement the command line runner and you override the run method. Now, whatever you write here runs as soon as the application starts. And when does the application starts? Application will start. Okay, 2 people are in wait room. Let me add them. Okay, so application will start as soon as this line will execute. So as soon as this line number 20 gets executed, the application start, and as soon as the application start, whatever you have written in this run method will get executed. All right, now let's create an object of Microstream. Let's write here Microstream equals to new Microstream. Now we are going to use an all args constructor to create an object of Microstream class inline. So course name will be Spring Boot. Today is fundamentals. Course type is IT. Instructor name is Samarth Narula. Let's sys out. Let's say Microstream object. Let's save this file and let's see in the logs. All right, one question to you guys. As I just explained, okay, we have not overridden the toString method. That's why we're seeing this hash over here. Let's override the toString also. I think we forgot to override the toString. So we have overridden the toString. Now we should see the proper response below. So here you can see that it is printing the Microstream object. We can see the course name, course type, and instructor name. Okay, one question to you. If I write, let's say, a sysout statement here, what will get printed first? Mean or the run method content? I think you have understood the question also, right? If I save this file, what will get printed first? Just want to see, I just explained it, like when this will get executed. So what will get printed first? Like this line or these lines?
The static block will be read first.
Okay, so you're saying this line will get executed first. This is the main method. So how many of you think that main method will get executed first? Actually, let me give you the answer. This will not get printed first. As I explained, as soon as the application starts when this line is executed. And as soon as the application starts, whatever you have written inside this run method will get executed. And then it will continue the execution. Then it will print this line and it will do the other things. Let me save this file and demonstrate the same behavior. So you can see it is first printing whatever you have written inside this run method, and then it is printing this. Because as I mentioned, command line run method gets executed as soon as the application starts. Application is not starting after completion of line number 22. Application is starting on execution of line number 21. And as soon as the application starts, it will execute whatever you have written in this run method. Is it clear?
Can we change the run method name, or is it default by
Which
Spring
name?
Boot? The method name run.
So overridden.
Because
Where you're saying?
no,
Override?
that's Spring Boot application dot run, that method is there. No? So that method name, can we change it?
No. It's your overriding, and that's why you cannot change. You can create your own method, but it will not run because it's coming from this command line runner interface, right? So how will you override this?
Okay,
I mean,
it's a
you can't
default.
change. It will become a new method.
Okay.
All right. So this is done. You have seen how you can use command line runner to test your application. It's time for you to learn about Lombok Framework. So as part of this hands-on, I'm going to give you introduction to what is Lombok Framework. So Lombok Framework is basically a framework which helps you to avoid a lot of boilerplate code. It provides you annotations which you can use in place of writing or generating getter methods, setter methods, toStrings, equals, and hash code. Your all args constructor, default constructor.
Sorry,
And
can I ask a question?
hello. Yeah, go ahead.
Concerning the run method, I just want to know, using the command line runner, is that how we can run, for example, let's say we want to install like maybe a JavaScript framework like React or Angular. Is that how we can?
No, don't get confused. Actually, the class name, the interface name is command line runner. It's basically
Yeah.
doing this only. Like it's giving you this run method, and the Spring Boot is a functional interface. So it has this like behavior in which whatever you write in this run method gets executed as soon as the application starts. So it gives priority to the content of this over everything else in your Spring Boot application in terms of execution.
Okay.
So just keep it simple. Whatever you write here will get executed as soon as the application starts, and then rest of the things will get executed. So application starts on this line, on execution of this line. So my application has started when this line run. So it will then run whatever is inside here, and then it will do rest of the things. Let's say before starting your application, you want to, after starting your application, before you do anything else, any business logic, you want to check something. Okay, you can check that over here. And if the check fails, you can just terminate your application over here only, like using system.exit and exit it abruptly or gracefully.
Okay, thank you.
All right. All right. So Lombok Framework is a open source framework. You can also search Lombok. Project Lombok. Okay. This is their official website. Although they had documentation here, but I think they have changed the page. So I'll be teaching you all the annotations of Lombok frameworks, the general annotations that we use day to day. So basically this framework helps us to avoid a lot of boilerplate code. All right. And for your Lombok framework, there is also a first time configuration that you have to do with your specific IDE. So as part of this hands-on, I'm going to show you the configuration that you need to do with your Eclipse IDE. Let's go here. So after you have added the Lombok dependency here, this is your Lombok dependency. After you have added your Lombok dependency here, you need to configure the Eclipse IDE to connect with this. How do you confirm, first of all, your Eclipse IDE is properly configured is you just go to this help about section, you scroll down. Here you will see Lombok version 1.18.6. This means if you're seeing this Lombok over here, that means your Eclipse has been successfully connected with the Lombok. If you're not seeing this, that means your Eclipse is not successfully connected to the Lombok. Okay. Now, how to connect your Eclipse IDE with your Lombok jar? After you have added this dependency, just search for the Lombok jar in your local. So I'll go to the Maven dependencies and search for the Lombok jar first here to see the path, exact path. So it will be like, just help me in searching the Lombok if you see it before.
It is after log 4j L.
Above or below?
Just after log.
No.
I think in your section it's not.
No, Lombok is here. We just need to search. Either it will be like, it will be only Lombok, I think. Just let me type L. Yeah, see, I got it. Here it is. So it is in this directory, C users divya.m2 repository or project Lombok. So let's navigate here. C users divya.m2 repository org project Lombok. Now Lombok 1.18.22. And once you locate this jar file, double click and run this jar file. This is the tricky part now. It will automatically scan your drives, your hard disk, and detect your Eclipse exe files. So give it that time to scan it. Once it has scanned, it will just show here. You can simply select it and click on install and update. Once you have done that, then click on quit installer. After quitting the installer, come back to your Eclipse IDE, restart your Eclipse IDE, just close it and start it again. Okay, just close it and like start it again, not minimize. I'm just simulating that. You need to actually close it and start it again. And after starting, you need to do project clean and clean all your projects. So these are the steps which you need to take after you have added the Lombok dependency for the first time. This is only a first time configuration. You'll not have to repeat this configuration each time you import a new Spring Boot project. This is only once for one Eclipse IDE. And if you're using IntelliJ, in IntelliJ, I think in 2022 versions, Lombok is not supported, but till 2021 versions, Lombok is supported. You need to go to the IntelliJ marketplace and install the Lombok plugin in order for the Lombok to be supported. So you need to remember this, okay? All right. So some of you who are using IntelliJ, you can just do this configuration right now. One thing to remember, if you just check your, if you're using, sorry, Eclipse, you can do this configuration right now. One thing to remember is your Eclipse version should be max to max 2021-06. After that, I've seen issues with the Lombok. So just ensure that your version is this 2021-06 version last. After that, there are some instabilities between Lombok dependency and the IDE.
Is there any way that we can use Eclipse Marketplace to install this plugin?
No, no one has created that plugin yet for Eclipse. I mean, you can just create this plugin. I've shown you the steps, manual steps. So you can automate and create a new plugin. But for that, you'll have to study like how to create these Eclipse specific plugins. And yeah. All right. So these are the steps, first time configuration steps. And maybe sometimes you might have to do right click Maven, this clean and install, run as Maven clean and install. And also sometimes Maven update project and select this force update of snapshots and releases. If there is some dependency issue, this will fix, it will remove the dependency with the prior version and will override it with the new version, whatever you have mentioned in your POM file. The same version it will add to your .m2 folder and refer to that in your project. Okay, so this is done. Let's quickly summarize. I'll give you a 1 hour lunch break in which you can also have your lunch and also try to configure your Lombok into your Eclipse IDE. And after break, if you face any issues while integrating Lombok with your Eclipse IDE, I'll help you solve your problems, like to connect it. Okay. So I'll put a timer now for 1 hour lunch break.
Samarth, what is the location that we need to specify here? Is it an Eclipse homepage or Eclipse plugin folder?
It is a, okay, let me tell you that. Give me a moment. Okay, which folder? Okay, 1 minute. Okay, this you need to just, not folder, you need to provide the exact exe file. Let me just load this. This will get loaded. Meanwhile, I'll set the timer. Let it load. Otherwise, you can manually specify the location by clicking the specify location.
Yeah,
okay?
so as part of this button, like what is the location that we need to select?
So that is the location where your Eclipse IDE is located. For me, let me check where is it located. Right click.
Home directory of Eclipse.
Yeah, I'm just checking where it is in my local. So it is in user folder, Eclipse folder, user folder. There is a Eclipse folder. Here it is inside JE03 Eclipse. You need to give this exact path with / like \exe eclipse.exe.
Okay.
So if you let this see, this has detected all the Eclipse IDs that I have. You see? And this is the last one which is supported with Lombok 2021-06. Maybe 09 is also supported, but 2022 versions are not. Once you select your respective one, just click install update and then click on quit installer and restart your Eclipse IDE. You can try this out, and if your jar file is not running, in that case what you can do is, let me show you how you can run. You can open command prompt here again. If you have set the JDK path correctly, So what you can do is you can use the java-jar command and run this same jar file again. Like it's same as double clicking and running. So it has opened this up. Okay. All right. I'll start the timer and see you after the lunch break. We'll meet again at 1:30 or 1:37 p.m. So meanwhile, just try to do this also. Try to configure Lombok and keep.
Okay, thank you.
Right. Thank you guys. See you after lunch. Hello, everyone. I hope everyone is back from the break.
Yes.
Yes.
For the guys who left and are rejoining during the break, I'll readmit you in the 5 minutes duration. I'll just check. All right. So let's get started. So last we have completed till here. So have you guys tried the first time configuration for Lombok in the break?
Yes, it is done from my end.
Anyone struggling?
I'm a bit struggling with the IntelliJ, but it says we can configure with old IntelliJ. So I downloaded old version. Yeah.
Yeah, I think I told you, right? In 2022 version, I had also faced a similar issue this year in Office. So I decided to, navigate, install the 2021 versions of IntelliJ. I don't know why these guys are not allowing the support in the latest version for Lombok.
Yeah.
Although it's a very helpful framework in avoiding a lot of boilerplate code. All right. So I think
Narula,
you go ahead.
yeah, is there any drawback with the Lombok?
No drawbacks. Only advantage.
Okay.
One reason can be when Lombok has to be integrated with the IDEs, right? So they must be thinking like why to have an external dependency when the IDE is created by them. So that's why I think they must have, removed Lombok support, but they have not made it official. They have just done it under the hood in the latest versions.
Okay.
And we developers are analyzing this. Maybe some changes must be done in IDEs, which is not allowing support to Lombok anymore. But we can, the jar file that you build will work in any server. So it's just the IDE problems. Okay, this is not a problem with the Java code. This is a problem with the IDEs that are the latest releases of all IDEs. Maybe they might fix something, right? So, all right. So first time configuration, has anyone else struggled, would like to get answers or solve the configuration problem for? If everyone has successfully configured, then I'll move to the next.
Yes, we can move.
Okay, we'll move to the next hands-on. So welcome to this hands-on. Get rid of boilerplate code with Lombok annotations. So here in this hands-on, you will learn how to avoid boilerplate code of setter method, getter method, and toString method. Then you'll also see how to fix the issue in the auto-generated code in the background by Lombok Framework. So the issue that you can fix is very simple. You can fix it by doing project clean if you face any compilation issues because of Lombok Framework after you successfully configured it. You can just do project clean and that issues will be solved. All right. Let's see if we have the Lombok dependency in the POM file. And we have the Lombok dependency in the POM file. All right. Now let's go to Microstream. This is our Pojo class. Let me stop the application and minimize it. So as part of this hands-on, we're going to generate getter methods and setter method with help of Lombok and toString also. So let's remove all these things. So I've removed all the getter setter methods. Let's remove toString also. Now that we have removed toString, we might get some compilation issue. Okay, we're not getting compilation issue because we have not removed all args constructor. Only when we start the application, we'll see a hash code for the Microstream because we have removed the toString. It will get printed because we are not using setter methods also. We are using all args constructor. All right, so our Spring Boot application has started. And here you can see, since we don't have toString method in the Microstream class, we are seeing the hash code. Now let's generate everything that we want to generate as part of this hands-on. We want to generate getter method. So we are going to use Lombok annotation @getter. We want to generate setter method. So we are going to use, before I generate the setter method, let me show you the skeleton of this project. So you can press Ctrl O on your keyboard and you can view the skeleton of your project. You can see that we have all args constructor, hash code, equals, and we have the getter methods for these three fields. We don't have setter methods. So these three getter methods are auto-generated because of this annotation @getter. I have not written getter methods here. There is no getter methods. So this is getting auto-generated from this annotation. Now let's add here setter also. Let's again press Ctrl O. Let me just take it below. Now you can see we have setter methods also, but we don't have toString. So let's generate toString also. Let's save this file, press Ctrl O. Now you can see we have toString also. So this is how you can generate your getter methods, setter methods, and your toString methods with help of these Lombok annotations. So you can see these are Lombok annotation. See the import statements. And if you're not able to view the outline by pressing Ctrl O, in that case, you can go to Window, Show View, and search for outline. Here you can see I have the getter methods, setter method, toString, the fields, all args constructor, and everything that this class has. I'm able to see the outline basically. All right, so this is done. So you have also learned, like as part of this hands-on, how to view the outline of your class in Eclipse. Any doubts?
No, no doubt.
All right, let's go back here. Let's summarize this. So as part of this hands-on, you have learned how to avoid boilerplate code of getter, setter, and toString method by using Lombok annotations @getter, @setter, and @toString. It is very easy, right? Using Lombok. Fix for common compilation issues. Then you have learned two ways to view the outline of your class. One is by pressing Ctrl O, and next is that Window Show View Outline to view the outline tab. All right. Now it's time for module 7, understanding the controller tier. First, I'm going to give the context, a little bit theoretical context of what is controller tier. Then I'll explain it with practicals. So introduction to controller, mapping method, and dispatcher servlet. You need to understand dispatcher servlet for mostly for your interviews, for your work. Even if you know the practical stuff, it's good enough. But for the interviews, sometimes they ask what is dispatcher servlet. All right. Okay, one more student is joining in. So what are controllers? Types of HTTP methods and mapping in Spring Framework. What is dispatcher servlet? So let's start by understanding what are controllers. So controllers are simple Java file in Spring Boot that are marked with either of the two annotations, either @controller or @REST controller annotation. Any Spring Boot class you mark with this annotation becomes your controller class. Now let's understand the types of HTTP methods and mapping and their corresponding mapping in Spring Boot framework. So HTTP method, for get method, we have this annotation @get mapping annotation. For post, we have this post mapping annotation. For delete method, we have the @delete mapping annotation. For put method, we have the @put mapping annotation. For patch method, we have the @patch mapping annotation. Very simple, right? So you must be knowing, right? Get methods are used for fetching some data. Let's say fetching some data from the database. Post method is used for, let's say, inserting some records in the database table, or let's say inserting a single record in the database table. Delete method is used for deleting a record in the database table, or maybe deleting few records from a database table. Put method is used for updating the entire row in the database table. Patch method is used for updating a certain part in a particular row in the database table. So these are the HTTP methods And in Spring Boot, you're going to learn the use of these mapping annotations to write the APIs, like corresponding APIs for these HTTP methods. You'll write a get API with this annotation, post API, delete API, put API, patch API. Although patch is not used that much, it is used in very rare scenarios. When the row value is too gigantic, that time you use patch because you don't want to waste your application performance in updating the entire row. Okay, what is dispatcher servlet? In Spring Boot, dispatcher servlet handles an incoming HTTP request. So from where does the request comes in? It comes in from the browser, right? And delegates the request to its respective controller mapping in controller file for processing and sending the response back. Let me explain this first, then I'll give a Q&A time. So basically, whenever you make a request from the browser, whenever, let's say you hit a get API, for example, this actuator was also a get API, okay? It was returning this response. So whenever you hit any get API, from browser, you can only hit your get APIs. For post, you need a postman, or you need to configure Swagger, or you need to use curl if you're using Mac, or you can use post Swagger API, which is enabled, okay? Anything, you can use postman also in Mac. So okay, coming back here. Okay, so whenever a request is made from the browser, requester comes to the Spring Boot Tomcat server, and in Tomcat, it has this dispatcher servlet, which basically has a work of delegating that request to the respective controller mapping method. So that it does with help of this. You'll understand it when we do the practical. So don't stress too much about it. In the backend, for if I go about explaining with the actuator, you will not understand, because for the actuators, we have not built these endpoints, right? This is built by someone else. We have just configured and we are using this actuator endpoint here. So I'll explain this in more detail when we build APIs as part of this course. So for now, you can just say that you have learned like what are controllers at a theoretical level, then different HTTP methods, and what is dispatcher servlet. You're going to learn these all these things with help of practicals. Let's get started with the practical. Hands-on. Understanding difference between @REST controller annotation and @controller annotation, and use of get mapping annotation. As part of this hands-on, you will learn about how to use these annotations, the @controller and @REST controller. Along with @controller, you will also have to use @response body annotation. Why so? I'll explain that with help of the practicals. And as part of this hands-on, you'll understand the difference between @controller and @REST controller annotation. So basically, your @controller annotation is your normal controller annotation, which was existing from before. Then Spring Boot guys, Pivotal guys improvised it. They created this convenience annotation, which is @REST controller annotation. Why this annotation is called convenience annotation is because @REST controller annotation is a combination of @controller and @response body annotation. So this annotation is a convenience annotation because it's a combination of two annotations, these two annotations. Then you're going to learn the use of get mapping annotation for creating a RESTful get API and how to test it from our browser. So we are going to create a RESTful get API as part of this hands-on. So let's get started. Let's come back here. Let's close these tabs. All right, let's expand the controller. Let's expand this Microstream controller. All right, let's create a new API here. Let's write here @get mapping. We'll name it info. We are creating a very simple API right now. Then later I'll show you the above part, what I have done and why have I done that. And let me replace this also. I want to first show you the use of @controller annotation. @controller annotation is a class level annotation, so it has to be marked at a class level only. Let's write our method here. For now, let's say I will return Microstream, or you can return string also. Okay, very simple. Hello. I'm just creating a hello API first. All good things starts from hello world. Let's start this. Let DevTools restart this for us. All right, DevTools has quickly restarted this for us. We can use this. Go to our browser. Let's open this browser. Let's close the actuator tabs. Let's type here localhost/info. Okay, it's breaking. Let's see why it's breaking. So our application is running on, okay, our application is running on a different port. That's why it's breaking. So let's go to the application.property file. Our active profile set was UAT. Let's remove it. Let DevTools restart the application for us. It will restart the application on the default port. All right, let's hit it again. Again, it's breaking. Let's see why it is breaking. So our application is now running on port 8080. And we have written this info endpoint. Yeah. So it is breaking because we need this @response body annotation. As I mentioned, if you use @controller annotation, you need to add response body annotation because it's not a convenience annotation. And because of this, you see, you have to waste your time by adding this annotation. Okay, let's refresh this. Now it's working. So rather in office work, I don't prefer this @controller annotation. I'll tell you the use case when you should use that. But in general, I use the convenience annotations like @rest controller annotation so that I don't need to write this separate annotation and the boilerplate code of writing this annotation. Now see, this will also work. This is also working. Okay, so what is dispatcher servlet? So whenever a request comes from the browser, so in a request, we have this /info, right? It comes to the dispatcher servlet. Dispatcher servlet then comes to this controller file and tries to match and find this info part. And it finds, okay, this info part is here, okay, in the third part here in the non-commented code. So it will execute this method. So this method is called as HTTP method, HTTP get method. Basically, it's a HTTP method because it's a API method. Other terminology for this is API method. This is called API method. And this is your mapping. Okay, so this is creating your get API. Now you understand how it is creating your get API. This is your get API. It has got created because we have added this get mapping annotation and we have given this prefix. Okay, you need to add this in order for this API to get created. All right, is this clear? This is the very basic start of API creation. That's why I just made the example very this. Okay. Any questions? Any other? Like, sorry to interrupt.
Can we have same two endpoints?
No, you cannot have two same endpoints. The URL, this needs to be different. If this is info, that other API endpoint should be different. You cannot have this. It will be ambiguous. It needs to be like this. And it's asking for method name also to be different.
Even we have to put the different method name.
Method name also and this API prefix also.
Okay.
So suffix.
Yeah.
It is localhost / whatever you write here. So these also needs to be different. If you create same, it will give error, I think, on API execution or while forming only. See, it is giving error here. Because how will dispatcher servlet come to know, like to navigate to which method if both are having same this? Because it is dispatcher servlet is mapping against this suffix part, the whatever you have passed here. Okay, it's called whatever it's called, this value. This is called get mapping value. Yeah, endpoint. This entire thing is called endpoint, get endpoint. But this is the prefix suffix of that endpoint, right? Info.
Yeah.
So you see, I was right here. It's saying this ambiguous mapping. Because if you understand what is dispatcher servlet, you'll understand whenever you are about to make this mistake that, okay, dispatcher servlet will break because of this mistake.
Okay. Yeah.
But I think you can have with some URI, you can have get and a post.
Yes, that you can have. A different, this can be done, but I'm about to teach post mapping, right? Not taught yet. So you can have a post mapping. This will work. This is not ambiguous because in a request that comes from browser, it has these things. It has the which kind of a method it is. It's a get method, and this is the prefix. If you're making a post method call, it will come here. It will first search for post method, then it will search for all post method which is matching with the suffix that you have passed in the browser. Okay.
Yeah, okay.
So this will work. This post API will work, but you cannot execute this post API from browser. It has to be executed from Postman or from Swagger API, Swagger UI or curl command. All right. Coming back to the slides. So you have learned the use of @controller, and you know that if you use @controller and you need to use along with this is the response body. I'll tell you when you have to use response body with controller. If you are returning any class type, okay, any custom object like string, or let's say if you're returning Microstream, then in that case you have to use response body. If you're returning a primitive data type like int or double, in that case you don't need @response body annotation, even if you have used @controller annotation. Okay, you can remember this. Next is, okay, I prefer this because it's a convenience annotation. I don't have to worry about all of that. And if you're creating a UI with Spring Boot with help of time leaf dependency, okay, in that kind of a scenario, let me just scroll it down. In that kind of a scenario, you will have to use @controller. In that case, you cannot have response body, right? You're returning a HTML page from here. So in that case, you'll notice that whenever you use time leaf and you define that mapping of pages from here, you use @controller mapping annotation. For this, you can refer the coronavirus tracker application, which I had built during COVID. Yes, this one. In this project, I had used the time leaf dependency. So here you'll observe I had used @controller annotation. So you can refer this repository for learning time leaf. Although I won't advise you to build UI with Spring Boot, because Spring Boot is not meant for UI. You should use UI frameworks like Angular or React or Node or MERN-Stack. But I mean, don't use Spring Boot for UI. It's not that good. Okay, it's good for creating APIs. For UI, use UI specific frameworks. Coming back here. Now you understand the difference between @controller and @rest controller, right? Can anyone quickly tell me the difference between @controller and @rest controller?
Yeah, controller required @controller along with @response body, and we can use time leaf when we are using @controller, but we cannot use that for @rest controller.
Correct.
And the rest controller is combination of @controller and @response body.
Correct. And in @controller, when do you have to use @response body? In which kind of return types?
When it is for some custom class or some string like thing.
Correct. Correct. I mean string class or custom class. But if you have a primitive data type like int double, in that case you don't need @response body. Correct. Perfect. And when do you use get mapping annotation?
Or get API.
Correct. Correct. Simple it is for get API.
And Samarth, there is something like I have read that a REST controller will return in JSON format.
Correct.
Yeah.
It is also a difference, I think.
Yeah, controller can return time leaf and JSON both, but REST controller only return JSON.
Correct. Correct. Yes, that's true. You can change it to XML. There are some properties for that. You can just check it out on Stack Overflow. Nowadays, no one prefers XML, right? Everyone prefers JSON only.
Yeah.
JSON and some like in Kubernetes or DevOps guys, they prefer YAML. It's all different. I mean, I personally prefer JSON because in YAML, linting matters. In JSON, linting doesn't matter. All right, coming back here. So I think this is good. You have understood the difference between controller, REST controller, and use of get mapping annotation, and the difference between both. let's start by creating a post API now. Now that you understand the get API, we will now create a post API. Okay. Before we create a post API, this was a very simple example which I created for you. Let me take it one level above. So this is a normal. Let me just copy the info. Okay, let me just uncomment this. Let's go inside this. So I'm basically just creating and returning an object of Microstream. All right. So now you understand this thing also, right? Instead of returning a string, I'm returning a custom object which I've created, which is a Microstream class, which we created, right? With course name, instructor name. So the first field is course name, second is course type, third is instructor name. All right. So similarly, we want to, let's say, send a custom information. We don't want to send this hard-coded information. We want to take this information from the customer or from someone else and set it and return it to them, okay, in this object. So we have created this custom info API, which is a post API. And you can see just the mapping is different. The rest all things are same, and the prefix I've just used different, but you can use info also if you like. Same, this is okay as long as the mapping type is different. All right, let me open Postman. So I've installed Postman as a web Chrome plugin. You can install it as a desktop app or as a plugin. Guys, if I'm going very fast or if I'm speaking very fast, please let me know, because there are students from all around the globe. So if you feel that I'm speaking very fast, let me know. I'll speak a little slow so that everyone gets the most out of this course. All right. So this is how you basically write it. So see, I'm writing like HTTP : / localhost : 8080 / custom info. So this custom info is this, okay, / custom info. Then is the interesting part. So these things go as query parameters, okay? And whatever goes as query parameters, this is the format for query parameter. Question mark, this field name, like this parameter name, which is course name, you just copy it exactly like this, paste it here, and you give the value, whatever value you want to give. Let's say the value I want to give is Spring Boot, Spring space, this is space character and boot. For space, we write %20. Now for the next field, course type, the separator between two fields is this AND operator. Okay, this implicit or AND, whatever. This AND operator. Then you write course type equals to IT. Then again, we had the third parameter, which is instructor name. So again, we write this AND instructor name equals to Samarth, then space, which this %20 and Narula. And then we click on this send. So you can see it is returning me the same response, because that is what we have done. We have taken the custom info from the API and we are setting it to the Microstream object and returning it. So I've done it through this service method. I'll come to the service method later on. For now, what I'll do is I'll just copy this implementation from here and paste it here so that you understand what we are doing. Okay, this makes more sense, right? We're just taking this from here and setting it here and returning it back. Same thing. So post API is used for basically inserting some value or for passing some custom value, you can say. Basically, the main purpose of having post is to insert a value, which you will understand when we'll move to the H2 and the JPA module. So any questions? All right. So I think everyone is clear.
This post mapping, we can use it from browser also, na?
No.
Without Postman?
Browser doesn't support. You can't make post calls from here like this. No? You're thinking what if you could execute it like this. So this is not supported. See.
Okay.
get is supported. This is a post API. That's why it's giving this error message. Request method. By default, it sets as get only. You can't do post. Here, see, you have selected this post, right?
Yeah.
That is how it works. In browser, it's get only.
Okay.
All right. So this hands-on is done. So in this session, you have created a post RESTful API, and you have installed, basically I've installed through this Postman plugin through Chrome browser. You can do the same, go to Chrome Marketplace and install the Postman plugin. You will see an install button here in Chrome Web Store. Okay. And you can use it to test the post APIs. Although I'm going to teach you Swagger UI as part of this course, so you'll not have to use Postman also, for at least for your Spring Boot application, but you should know how to use Postman or either the curl commands, because in general, not every application developer will give you Swagger UI, right, or API documentation. So you should know how to use those tools also in general. All right. Now let's further cut down. Okay, next hands-on is about further cutting down all the boilerplate. Okay, let me see, we are in correct place, right? Okay, next hands-on is about further cut down boilerplate code of Lombok annotation with one Lombok annotation, which is @data. This is very simple. Let's go back to the Microstream class. Here, instead of using so many annotations, even Lombok provides a convenience annotation, which is @data. Now let me import this. @data annotation is a combination of @setter, @getter, required args constructor, @toString, and == and hash code annotation. So it's a combination of all these annotations. This required args constructor annotation, I think this you have not studied. So this, what it does is, like, whichever fields are marked as, let's say, private final string course name, so those values have to be set while object creation, right? Because they are final. So it will by default add them in the constructor. Only the final fields it will add to the constructor, rest it will not add. That's what required args constructor means. The parameters which are mandatory to set, it would create a constructor only for those parameters, which are basically like private static final or private final fields. Okay. Now let's save this file. So we have added a convenience annotation, and in the main file, although we are printing an object of Microstream, so we can just see over here, it is still working. So this means that our toString method has now come from where? It has come from this @data annotation. So any doubt about this hands-on?
No, Samarth.
All right. So as part of this hands-on, you have learned the use of @data annotation, which is a Lombok annotation, and it's a convenience annotation offered by the Lombok framework. And it's a combination of which 5 annotation, guys?
@getter, setter, toString, and there were 2 others.
@required args constructor, and I think == and hash code you mentioned.
Yeah,
toString,
yeah.
hash code, required args constructor, getter, setter. I think 5 are done.
Yeah.
Okay. Now introduction to Swagger API. Understanding and configuring Swagger UI. So as part of this course, we are going to configure API documentation with help of Swagger UI. Like, we are going to enable this Swagger UI. And the dependency we are using is the Swagger Fox dependency. Now, in the latest version of Spring Boot, which is like 2.6.3 onwards, or maybe till 2.6 it works. But from 2.6 and above versions, I've seen that Swagger Fox dependency is not working. I've read a blog about it in which they had mentioned that they discourage the use of Swagger Fox because one of the dependency in the Swagger Fox and in the Spring Boot parent had a collision. So they recommend using some other framework for creating, maybe Open API framework for creating API documentation. But as part of this course, we are going to create API documentation with Swagger Fox. This is also nearly the latest one, right? And in the latest one, the very latest one, there are many issues with Lombok, issues with Swagger. So because they don't want the external dependencies to be dependent on their framework. They want to make Spring Boot independent. Maybe because of that, they're removing the support. They might bring some of their own dependencies for these things maybe in future. Okay. All right. So here, introduction to Swagger and how to configure Swagger. So this is the configuration package com.microstream.config, and this is the Swagger config file. Let me close the other tabs. So this is the Swagger config file. Here you can see that, just ignore this part for now, it will confuse you. Okay, now you can see that this is a very simple configuration class. It's a Swagger configuration class. Since it's a Swagger configuration class, this class has been annotated with @enable Swagger 2, and we have the @configuration annotation here, and we have defined a bean. Now, if you're wondering from where are these imports coming from, these are coming from the Swagger Fox dependency, which we have added in our project. So if you go to the POM file, these are the two dependencies you need for the Swagger Fox enabled. First dependency is Swagger Fox Swagger 2, and for creating the UI, it is Swagger Fox Swagger UI. And version has to be same for these two dependencies. They have to be compatible one. Okay, this is the bean. Now, don't get confused when you look at this code. It's little bit of a configuration code. What you can do is you can copy paste this class exactly like it is in your new Spring Boot project. And you need to take care of this part. APIs, request handler selectors, base package. You need to give a proper base package here. You can either give this base package, but that leads to problems sometimes as per my observation. So what I prefer is I prefer giving the base package name of the controller package. In the base package name, I'm providing the name of the controller package. So whichever is your controller package, just provide that controller package name over here. That's all you have to do to configure Swagger UI. And just don't even call this by heart, this configuration. Just copy paste this class and replace this and add these two annotation, these two dependencies in your Spring Boot project and this class, and replace this, and it will work. And this group name also you can change as per you need. This is what will be visible on the Swagger UI page. Now that we have enabled the Swagger UI, let's just execute the same APIs from Swagger UI rather than Postman or browser, directly from browser. Okay, let's open a new tab. Let's navigate to Swagger UI. So Swagger UI will be available on this URL, which is your localhost :/swagger-ui.html. Here you can see your Microstream controller, the one which you have created. This we are going to create in the later part of the course, or maybe understand in the later part of the course. So for now, focus on Microstream controller. Here you can see your two APIs. This is expandable. These are the two APIs, the info API, which is the get API, post API, which is the custom info API. Guys, by 3 p.m. we'll start the Microstream part. Whatever will be left for today, we'll do it tomorrow, okay? For this fundamental part. And once fundamental is done, we'll continue with the advanced part tomorrow. Because 3 to 4 is the Microstream part. I'll have to teach that part in the last hour. And if that's done in half an hour, again, we'll continue with this. If the Microstream part is done in half an hour. If it's not completed in half an hour, we'll go on for the 1 hour or whatever duration it takes. Okay, so coming back here to the get info. So this is a get info API. You can execute it. It's the same thing which we have created. We are executing from here. So you see how simple it was. Try it out, execute, and it executes. Here you see the response body. Here you see the HTTP code. And below is the API documentation that you don't need to so much care about as of now. This is the meaning of different HTTP codes. What does 401 means? Unauthorized. 403 forbidden. 404 not found. And some response headers that you get along with this response body. So these information you can get it over here very easily. Similarly, you can also execute custom info. You can provide your course name over here. Let's say Spring Boot with Swagger. UI, course type IT, instructor name Samarth, execute. So here you can see you've got the same response back. So you are able to execute your get APIs and your post APIs by using Swagger UI. Is this clear to everyone?
Yes, Samarth, I have a question. Like, we can run all this command only when we are running that app in Eclipse. Am I right?
No. You can run these commands. You mean to say this, right? Swagger UI.
Yeah, Swagger UI.
No, you can access it from any IDE that you run. This is your application specific. It's not your
No,
IDE.
I'm saying like in Eclipse we have to run that microservice project. I think.
Yes. Obviously,
Yeah,
this
yeah,
is
that.
accessible on your embedded Tomcat server, right?
Oh,
So
yeah.
this will only be accessible when your application is running because you're executing your actual APIs.
Okay.
This is not a same response. This is actually executing your business functionality.
Okay. Yeah.
So in your production, if you have any financial data which you don't want to expose, in that case, don't enable Swagger UI for the production environment. Just enable it for your local and development environment where only the trusted people can execute it. Okay. Or otherwise you'll have to add authentication for the APIs so that unauthorized users won't be able to access it. You are going to learn about authentication part tomorrow in Spring Security, don't worry. So now you understand, right, what all steps you have to do to configure Swagger UI. Can anyone quickly tell me the steps you have to take to configure the Swagger config? First step is?
Add the dependency in the form file.
Mm-hmm. Yeah, go ahead.
Yes. Then we have to add the group name and the package in the config class.
Correct. This group name.
Huh?
This group name is visible
same
here.
as it will be only.
Yes, that's all it is. Like simple, right? Even if you forget this, you will only see this name if you copy paste, but this you need to write correctly. If you make a mistake here, you know what will happen. Let me show you. If you make a mistake here, you will not see any of this. Okay, it's still catching. Okay, let me give a very wrong name then. Let me give something like, let me remove the start part. See, it's not able to create your Swagger UI because it starts the scanning from here for creating that Swagger UI. Okay, so that scanning starts from this package name. So just ensure you give the correct controller package name here. Or maybe you can provide the base package name also, but I have seen errors with that in some of the applications. So let me show you if maybe we can replicate those errors here. See, right now you're seeing models also below, right? So in this application, it's not giving errors, but in general, what I have observed in my office experience is it's better to give a this controller package name than your base package name. So do remember this. If you face issues, just use this trick. Okay. Okay, this part is already done. You understand, right? What is Swagger API? So it's a Swagger Fox framework. It is used for generating API documentation. It helps the developer to rapidly test the API. So you saw how fast we could test the APIs by using this Swagger UI, right? It was so fast that we could easily test our application with help of this. So it basically enables rapid API testing. It also bridges the gap between developer and business analyst, because business analyst guys will not understand your APIs, right? But if you show them through this Swagger UI and you show the response that they're getting, so they can understand, okay, this is the business data that I'll get. So with help of Swagger API, you can also bridge the gap between the developers and the business analyst. So you have learned, like, as part of this hands-on, which dependencies are required to be injected in POM file for creating in Swagger UI. There are two dependencies. One is the Swagger Fox API and the one is the UI dependency. You just need to add those dependencies. You can refer this project and add it. You need to then create this Swagger config file. If you want me to explain, I'll explain you. It's very basic. You just need to create a docket. You need to mention the documentation type, which is Swagger 2 in our case. This can be like if later more versions are released, there can be like Swagger 12 is also there. So you can just choose the design of your Swagger documentation. Let's see what happens if we choose 12. It will be little different look. So I am more familiar with 2. That's why I use 2. See, only the coloring has changed a little bit. Not much difference. Okay. I'll just make it the color which I like, which is 2. Then the group name, then you have to select from where to pick and create the Swagger UI. So select APIs, and APIs are in which package? They are in this package. And this is the kind of a builder design pattern. So that's why in the end you write .build. So have you understood like how this has been written? And since it's the configuration class, so this is more of a configuration. That's why we write here @bean, and this gets loaded into the container on application start. I didn't want it to confuse you. That's why first I showed you what this exactly does and what you need to remember. But this is just additional information about what these things mean. Okay. Any doubt?
Just one question. Is there any way that like we can avoid this configuration class here and have this configuration
in
directly?
property file?
Yeah.
I think there might be a way, but you'll have to find out, do some research for that, because I couldn't find that way long back when I created this project. So I'd use this way. I mean, in office work also, we used to prefer this one.
Okay.
There are multiple ways of doing same thing. Like in AWS, if you want to have a cross account access, you can either access through IAM role, and you can also access through, if you have Kubernetes, you can access through service accounts, right? So there are multiple ways of doing the same things. It's just that what we choose.
Okay.
Yeah. All right. I think it is possible through property file, but you'll have to find out.
Sure.
Next hands-on is customizing the API info. Now we have not customized our API info. Here we see this API documentation and some random stuff, Apache 2 terms of service. Even if you click, I know where it will land us. See, something weird. Let's configure this to be our application specific. So that we can do by creating this API info object. For creating this API info object, there is a builder design pattern which they have provided us, which is API info builder class. And you can just use this builder design pattern and set everything that you like set the title, the description, terms of service URL, contact information through which people can contact you if they are referring to your Swagger. Why you need to add this correctly, you know, let's say you are deploying these APIs and you are selling these APIs. Okay. See, API developers can once you've learned from this course, you can also create your own APIs and sell those APIs in the API marketplaces or on the internet, and you can earn through it a passive income, right? It's just a one-time work that you'll have to do. And after that, the cost that you'll have to bear is the deployment cost. Once you deploy the application and people purchase it and use it, so each like how much API they execute, according to that you'll have to pay. Or maybe for the EC2 machine, if you have used how many hours that machine is running for, you have to pay for that. Or maybe there is some limit, like I remember there's some limit, like some thousands of API calls or lakhs of API call which is allowed, and after that you are charged some very small amount per API call that is made. Okay. So is this clear? Like what is the advantage of creating this Swagger UI? You can also create your own APIs. For example, I had created a product, Instagram manager. In a single click, I can follow someone's followers. Like even if they have thousands of followers, I can follow all their followers in a single click. In a single click, I can unfollow all my following of all the people I follow. So basically, you can do all of that kind of stuff with help of API. So I had created that Instagram manager API based product. So you can also create your own products for a specific use cases and sell in the API marketplace or on the internet. So other companies who require it will purchase it. And if you have an idea about finance domain, if you know certain data processing, you can code that logic into and you can sell that APIs to some financial companies and do that specific kind of processing and earn through that. All right. So once this is added, if you want to add this to the Swagger UI, you have to add it to this docket also. So we can do it with this API. Okay, this is wrong one. I think I just typed P. It is API info. This is the one. And here I'll call this method. Let me add this dot here. Done. Okay, something is breaking. Let's see what is breaking. It says colon is missing. 20. Okay, we have double bracket, no single bracket here. Let's restart the application. Okay, it's fixed. I think it was an intermediary error. Okay, so now that we have passed this API info here, let's refresh this and let's see what we see now. So here you can see you're seeing this Bookstore API. You're seeing Bookstore API reference for developers, Bookstore API website link, send email to Bookstore API, Bookstore license. So you're seeing all these things now, right? This is because, sorry, here. You're seeing all these things now because you have added this API info. Is this clear? Like what you can do with this API info part?
Yes.
All right.
Yeah.
Let's go back to slides. Open API 3, and it's a good question asked by George. What do you think about Open API 3 and Spring Doc library? I think, George, from the latest version, very latest version of Spring Boot, like 2.6 above, or maybe 2.7 above what we saw today on Spring Initializer, we'll have to use Open API 3 or Spring Doc only because Swagger Fox is no more supported by them. So no problem, George. So from the very latest version, Swagger Fox is not supported. They have some conflict between the way the things are done. Yeah, so in that particular case, you'll have to use Open API 3 or Swagger Docs for creating the the API documentation or Swagger UI. But this is a very convenient and old way which everyone is to use. Old way in a sense, like till last 2 months, this was the most latest way, and just in last 2 months, they have a conflict because of which they are asking people not to use that and rather use Open API 3 or Spring Doc. There is no much good documentation on Open API 3 and Spring Doc, like not so much as it is for Swagger Fox. So maybe with time documentation will develop and adding it to the project would become simple for everyone. Okay, guys, so there was a question in the chat which I was answering. Let's move to the next one. Advanced concept implementation in controller tier. Okay, now you'll understand the use of @all-args constructor and @no-args constructor to further remove the boilerplate code of implementing constructor injection pattern. All right, let's go here. Let's go to the Microstream project. So how many of you are aware about constructor injection pattern? All right, it's not telescoping constructor pattern, not a Java design pattern, just a constructor injection. Okay, so here what we have done is like created an object with help of all-args constructor. This is only constructor injection pattern. Okay, don't worry. Now, instead of writing this all-args constructor here, we are going to enable this all-args constructor with this all-args constructor annotation. And we all know that once we create a all-args constructor or any constructor, the default constructor is taken away from us by Java. So we'll create the default constructor also. Let's remove this with help of the another annotation, which is no-args constructor. So with help of this, we are creating an all-args constructor. With help of this, we are creating a default constructor. That's all it is. Is it clear?
Yes, Samarth.
All right. So this is how you use these two annotations, Lombok annotations. Now, what is telescoping constructor design pattern? Now, telescoping constructor design pattern is a Java design pattern. So I'd added it to this course, but let me just explain you fast so that we can focus more on Spring Boot concepts. It is just like we have, let's say, 3 fields. How many possible constructors can be created with 3 fields? Any idea?
2.
3 factorial. Is 3 into 2 into 1, which is equal to 6.
6, yeah, 6.
So 6 constructors can be created with 3 fields. That is how you calculate number of fields factorial. So like one constructor can have all 3, one constructor will have only course name, one will have this, one will have this, one will have these 2, another one will have these 2. Okay, that is how it will become 6. So that is nothing. If you implement all possible type of constructors, that is only telescoping constructor pattern. Although it's not a very good design pattern, better design pattern is to use builder design pattern. So a better alternative to telescoping constructor design pattern is to implement builder design pattern. And writing a builder pattern is a lot of code. So we don't need to remember all of that code also, because what we can do is we can leverage the @builder annotation. So let's do that. Let's enable the builder design pattern here. Let's delete these things out. Let's import this. Control 1. So used to of IntelliJ. I was hitting option enter like this, alt enter here. I mean this. All right. So this is builder. All you need to write is @builder, and this basically enables the builder design pattern for you. If you want to confirm again, you can press Ctrl O. And you can press Ctrl O. Here you can see that we have the builder design pattern code. Here is the Microstream builder static inner class, which has got created with these 3 fields and all these things. So this is how you can enable builder design pattern code. Let me show you how to use this code. Although you have seen it with that new docket and that API builder in Swagger, this was also a builder design pattern code, which you see. But let's do it for our custom object, which is Microstream object. I'll just have some water. All right. So let's do it. All right. We have enabled builder design pattern here. We have the builder code in the background. Let's go to the main class. Instead of creating object by using all args constructor, what we would do is we would build this object inline. So let's use the builder design pattern here. All you have to do is write class name dot builder dot, let's say first field we want to set is course name. Let's set the course name as Spring Boot design patterns. Then let's set dot, next we want to set is course type. We want to set it as IT. Then we want to set instructor name. Let's set it to Samarth. Let's format this code, save this code, and let DevTools restart the application. So here you can see I'm getting this object. So I've created the Microstream object with help of builder design pattern. You see how easy it is. Okay, one last thing we have to do is dot build, so that we don't see this stream builder thing. It will return us the object inside. So now you can see we are getting a proper object here of Microstream. You see? So do you have doubt about how to use builder design pattern, or everyone has understood how to use builder design pattern?
What is the advantage of using this pattern?
You can create objects in line rather than in multiple lines. Now see, with constructor, what happens is it becomes very complex, right? I mean, if you have a constructor, all args constructor, for simple class like this, it is okay. But if you have hundreds of fields, in constructor, you'll have to set value for all those fields, right? But in builder, it is not mandatory. You can remove the instructor name. It will set the default instructor name maybe as null something.
Okay. Clear.
See, null. So this is the advantage of using builder design pattern.
Thank you.
Next is, okay, let's summarize this. So as, okay, before we summarize, anyone else has doubt about builder pattern, because it's very interesting concept and people find it difficult to understand a builder design pattern, but with help of this, I hope it would have helped with Lombok. If everyone is clear, you can, okay, free to go ahead.
Yeah, can you explain a bit more? Actually, I got some, didn't get clear things.
Okay, let me just make it, break it down to explain.
Yeah.
Now do you understand like what we are doing?
Okay.
We're creating object of Microstream using builder design pattern. And this is how you use the builder design pattern. You write the class name, you get write dot builder to start the builder pattern. And then for all your fields, you just write dot your field name, dot your field name. These are like methods inside it. And in the end, you write dot build, which creates the final object for you. Like before, how we were creating object, we were creating like this, right?
We are making constructor and then.
Yeah, with the constructor. So we can either create with construct.
Okay, so builder advantage is we don't have to create many constructor. Like if we make a constructor with 3 objects, sorry, 3 parameters, then we have to pass necessarily all these parameters. But with
correct. See, I cannot just skip this, right? It will give me error.
Yeah, got it.
But with builder, I have removed instructor name, but still it is working.
Yeah.
It is giving a default value null for the missed field.
Okay.
Okay, so this is how you can set. This is how you can use builder pattern. Let's go to, okay. If everyone is clear, you can write clear because it's a complex topic which we have covered. Okay. Now we'll come to complex object creation with builder design pattern. We will learn about what are complex objects and difference between simple and complex object, understand and implement complex object creation and builder design pattern. Okay, so let's make our object, which is a simple object right now, a complex object. This is a simple object. It has instructor name as type string. In order to make it a complex object, I'll just use a different class, which is full name. So this is a full name class, which has 2 fields, first name, last name, and everything that this Pojo class needs, toString equals hash code, everything that it needs, along with the builder design pattern. Okay, let me correct this. So these things also I'll do with builder code. Since @data has equals and hash code, I don't need to write it separately. See how neat and clean our class looks like. You see this? Okay, let's fix our code. Here also we need to fix. So here there are multiple places actually we'll have to fix. Okay, instructor name. Instead of this, we need to use full name now. Here again we'll have to fix instructor name. So this will have to become first name, or you'll have to split by string, space, last name. So this is fixed. Here we had all the removed. Here also we'll have to change. For now, we have not taught you the service part, right? We have not reached here. Let me comment out this class for now, because when we'll reach here, I'll explain you what are what are service classes. Okay, let's see. Application failed to start. Okay, I think this has been referred here. This is also fixed. Done. So coming to the complex object creation, let's understand how to create complex objects. This was simple object, right? Now you have a full name. Instructor name is a full name, right? We have changed the instructor name from a string to a type of full name, correct? See, it was string earlier. I've made it a custom object full name. Now you can use builder inside builder for complex object creation. Okay, then one more student has joined in. Builder dot first name dot last name dot build. So this is how you create complex objects with builder design pattern. Is this clear? What we have done?
Yes.
Can you please show full name.java? Okay, here also we have
Same thing, same annotations. Actually, you can just add this to all your Pojo classes and your work will be done. Rest of the things were for your understanding, like all the non-convenient annotations.
Do we need all args constructor and no args constructor? Like
That's your choice. If you don't want the all args constructor, I mean for builder, I think yes, it's needed because internally builder design pattern needs these two.
Okay.
But if you're not using builder, then it's your choice. Okay. So I think this topic is done. Let's move to the next one. You also understand like the difference between simple and complex object. Before what we had was having only string. That was a kind of a simple object. And then we introduced instead of a string for the instructor name as a full name. So it turned into a complex object. So builder design pattern is mostly meant for creation of complex objects. Otherwise, you should, for simple objects, you should use all args constructor. Without wasting any time, let's start the understanding of service tier. So hands-on introduction to service tier, and then, okay, it's just 2:46 right now, right? I was feeling it's 3:45, but yeah, 4 o'clock is the end. Okay, introduction to service tier and then creating service class out of controller methods. So as part of this hands-on, what we are basically going to do is, I'll explain you and do it directly. Right now, what do we have in controller class? We have this business logic, right? Whatever is this is the business logic. This should ideally not be in the controller class. This should be in the service class. So let's go to the service class. This is our service Microstream service IMPL class. Let's uncomment this. And this is a Microstream service, this interface. Let's make this changes. Let's change it to full name. Okay, we have fixed that. Let's fix this code also. I think I have fixed it already below. This needs to change. This also needs to change. Let's copy this part from the controller. Controller, we have made these changes here. Controls. Yeah, let's uncomment this. Let's paste it here. This would go like this. Okay. This log part I'll explain you later. It's another Lombok annotation. All right. So this is done. So let me explain you the service class first. Then we'll understand that. So you can see that this is a service class. This should ideally have all the business logic. But right now we have placed all our business logic in our controller class. This is the business logic. This should not be here. Let's close all the other classes. Okay. So since this is a service class, this class has to be annotated with @service annotation. And this is not required. You're not required to have a separate interface which your service class implements. This I have just done. Okay, so I'll just remove it for now so that it's more simpler for you to understand. This will make more sense. Since a service class, this is a service class, I've annotated this class with @service. It has these fields: Microstream service IMPL. This class has these methods, sorry, get info and get custom info. In this get info, we are returning a hard-coded info. In this get custom info, we are passing the same things and creating an object of Microstream class and returning it. That's all it is. Now we are going to leverage this class. So we want to change it to IMPL since we have removed that implements part. Let's paste it here. So instead of hard coding all the information here, the information is hard coded now to Microstream service IMPL. So this auto wiring, if you're thinking, it's nothing, it's just as good as this. So in Spring Boot, you don't create objects directly with new keyword. You don't do this. Rather, you write it like this. Okay. So we have moved this logic to our service class, this particular logic, and we are going to refer this logic from there. So let's write here okay, where is it? Let's write here Microstream service dot get info. Also, so that you don't get confused, let it be this only for now. Just don't get confused. I've auto wired the concrete class and not the interface. Okay, before I had auto wired the interface. I'll explain you how you can auto wire the interface and why you should auto wire the interface. It's just a good practice. I'll tell you why later. First, let's focus on the basic. So this get info here, this logic also I have moved to Microstream service IMPL. So this is the reference of this class object, and I'll be accessing get custom info from there and passing these same fields as it is over here, and done. So you see, now I have moved all the business logic from the controller class to the service class, and service classes are meant to have all the business logic. So that is what it is. So service classes are meant to have your business logic. So we have created the service class out of controller methods, then extracted out the service contract. Okay, let's do this also. Now that we have this service class here, let's extract out the interface from here. Let's check where it is. Source, refactor, extract interface. You can use this shortcut and extract out the interface and give some interface name that you like and click on OK. It will extract out and place the interface in the same package. So I didn't want it to keep the interface in the same package. So I created another package, which is com.microstream.service. And my service IMPL stands for implementation. So this class is implementing this interface. That's what it means. So I've placed the implementing class in this package and the interfaces in this package. Okay, this is how you can extract out. And once you come back to this class, you can just simply write here again, implements Microstream service. Okay, this is done. Now in your controller class, either you can auto wire by the concrete class or by the interface. Okay, so if I want to auto wire by the interface, will it work or will it not work? What do you think? If I save this file, will it work or will it break? It's just normal Java. Just imagine writing interface on the left side equals to new class object on the right side.
It will work.
Yes, it will work. So let's save this file and it will work. Okay, one more tricky question to you. This is an interview question. What will happen if there are two classes or two classes that implements this interface and you have auto wired the interface here? Which class object will it create here?
Code will break. We should use qualifier annotation.
Yes, you can use @qualifier annotation, or you can just mark one of the class as with the primary annotation. This is one more way. Or if you don't want to do any of that, what you can do is, if there are two classes, you can just copy the class name as it is and paste the class name here and make it camel casing. And if let's say there are two classes, Microstream service IMPL and IMPL2, if you pass this IMPL, it will create object of IMPL. If you pass here IMPL2, it will create object of IMPL2 class. That is how it will work. Okay. Another trick. Is this trick also clear or should I demonstrate? This trick you'll not find out. Yeah. Yes, Nitin.
Can you please repeat it?
Yeah, sure. I'll just show that trick. Okay, so if we have two classes, basically two classes that that implements this Microstream service interface. And if we write here auto wire, which object will it create? Will it create object of Microstream service IMPL class? Or let's say we have another class, let's do it. Let's create another class Microstream service IMPL2. Let's make a slight variation in this. Let's name it Yatin Taluja. A slight variation. All right. So this get info is returning this, and this get info is returning this. Okay. Now, if I want to create object from this auto wire of this IMPL2, what I need to do? If you have understood the concept, can anyone answer like what I need to do if I want to create object of this? In right now, if I just write this is an interface which has been extended, or sorry, which has been implemented by both the classes. So code will break, right? You can see here in the error, it's breaking, but two were found. This interface required a single bean, or two were found. You were correct of using @qualifier and @primary, but there is one more way which I want to show, which is a very tricky and a good way.
Yeah, as you were saying that like we can either use primary in one of the classes or try to use an object of one of the classes in the auto wiring.
That is one way. That is a way that is easily available on internet, like using primary or @qualifier. I think Shrisha has understood what I was trying to explain, the very tricky way. So you can read in the chat, guys. We need to give the reference name as this like this. Okay. So this class name is what? This class name is Microstream service IMPL2. Just copy it and provide the reference name like this. That's all. Now it will create object of this class. Let me fix the compilation issues. So you can see the code has fixed. Okay.
Samarth, just one question regarding this third approach. This is applicable in all Spring Boot versions, all that is latestly introduced.
You know the reason why? You know why? Because when component scan happens, these classes are loaded as beans in the container, right? So the naming that that Spring Boot does is like it names the beans like this with the class name in camel casing. So here you're just referring to that bean name. Internally, it automatically matches it. This is what I have found. Actually, this is not available on internet. And it works, right? We have seen it.
That's great.
How can we understand whether it will map to the correct implementation class?
Yeah, so you can, if you execute this get info, what will it give info for? You can see in Microstream service IMPL2 for the get info, it will return Yatin Taluja. And in Microstream service IMPL, it will return Samarth Narula. So right now, which object have we auto-wired here? Object of which class?
Look at the class name actually, but in a small case as a reference.
Exactly. So this will create object, and this is what? This is interface, right? This is the interface, Microstream service, and the reference name is a class name. So this will create object of this class. This writing like this is as good as writing. People who have very good understanding of Java will now understand what I am trying to explain.
All right.
Yeah, Java 8 feature.
Correct. It will
This is
create
polymorphism concept.
Correct, correct. It will create object of this class. Okay. All right. So this is done. All right. Now, if you want to verify whether it will print this, so what you can do is you can execute your get API. Since it is creating object of this, it will print Yatin Taluja as an instructor name. Let's refresh the Swagger UI. Expand this, get info, write out, execute. Here you see it's returning Yatin Taluja. Now, if I change the reference name to just IMPL, which one will it print? If I execute the info API, which one will it print now? It will print this. Correct. Correct. I think now it's clear, right? Always, whenever you change your APIs, don't forget to refresh your Swagger UI. If you're changing your service class, you don't need to refresh your Swagger UI, but if you're changing your controller class, do refresh your Swagger UI. Remember this. Okay, so this is done. Now let's do this last hands-on, then we'll move to Microstream part. And after Microstream, if time permits, we'll continue again with the Spring Boot part. Otherwise, rest of the modules will take up in tomorrow's session. And tomorrow we have a lot to do. Like tomorrow, we are going to cover a lot of other topics, which I'll discuss after by the end of this session, today's session.
Samarth, just one question. What is the significance of adding that service annotation?
Okay, actually, it's just for marking. So you can add @ component also, but it's a good practice to mark a service class with service annotation.
Okay, it is just a mark. I mean, nothing else,
Yeah,
right?
yeah. But in order for the class to, yeah, I mean, from the latest, from the 2 and above Spring Boot versions, even if you don't mark the class, it gets loaded in the component scan. Before it is to not.
Okay.
Okay, so I think this is good.
I have a question.
Yeah, right.
Yeah. Suppose when we create a container, we scan the base package, like the class with the configuration notation, right?
It will, I'm trying to understand your question. Whenever we,
there are a class called abstract annotation config, right? No, here normally when we create abstract annotation config classes, there we pass with that object we scan the configuration class, from where we scan other packages.
okay, that, okay, you are saying that, okay, see, the component scan starts from here and it loads the classes from all the sub packages.
Okay, but in Spring we scan the package, but here we are not in Spring. In normal Spring we scan the configuration class package. Through that we can scan other packages, right?
From here you can escape, you're saying, other packages.
No, I want where we are. I want to know where we are scanning this package Swagger config.
Trigger. Like, where are we escaping? Can you just type your question in the chat? Scanning. Okay, the scanning is happening when we start the Spring Boot application. It automatically starts from here. That is how framework is designed. Like, it will start scanning from here. We don't need to worry about that. I mean, Spring Core framework and all, you have to mention, right, from where to start loading.
Yes.
Here you don't have to worry about all of that. That is why people love Spring Boot, because you can focus now more on your business logic and less of the configuration that you had to do previously using that old legacy Spring framework. That is why everyone is moving to Spring Boot framework for microservice architectures. First of all, it's easily deployable. Also, these applications are very easily deployable on cloud. It's like production ready applications. All right. So I think that answers your question, right?
Yes.
Okay. All right. So initializing logger with a Lombok annotation @SLF4j. So let's implement this logger. Then we'll view the different levels of logging supported by Lombok annotation. Then we'll see some functional style of logging and testing our application with command line runner and Swagger. Okay. So in the service class, you can see that I've annotated this class with @SLF4j. So basically, by adding this Lombok annotation, it initializes a logger class for us, and the reference name is log. You can press Ctrl O. You'll see that logger has been initialized. You can use this reference and add info level logging with .info. So here I've just added a log statement inside getInfo method. Then here I've added next one, log info inside getCustom method. Now, whenever the info API will be executed, it will call this class method getInfo, right? And let's go here. Whenever this class is executed, it will print inside getInfo method. Let's test it out. Let's execute. Let's go back. Let's view the logs. Here you can see it has printed inside getInfo. These two you are seeing from the previous execution. Similarly, if we execute getCustomInfo, it will print this in the logs. This is the use of adding @SLF4j annotation. Basically, it is initializing a logger for us. We don't need to write that log factory logger equals to all of those things, get logger. So we don't need to do all of that. With this one annotation, it has initialized logger for us. Okay. Next is the functional style of coding. So let's go back here. Let's say I want to print this object. So I want to add a log statement. I have already annotated this main class with @SLF4j, which has initialized a logger for me with help of Lombok. Now I'll write here log.info. I'll use this one format. I'll say Microstream object, and here I will write like this. This is a little bit functional way of programming. And here I'll write obj. I'll save it and let's view the logs. So here you can see it has printed this. You see this? This is how you can leverage this and have and write little bit functional style of programming with help of this Lombok annotation with the format part. Okay. Is this clear to everyone? The use of this annotation and the functional style of logging that we have used. If it's clear, you can write clear in the chat. All right. We'll take a 5 minutes break and we'll continue with Microstream part after this. And once Microstream part is done, then we'll continue with the further part. And if it is already 4 p.m. by then we'll continue tomorrow with rest of the topics. This is a very big course actually. In 2 days, we have to cover everything. And I hope I'll start increasing the pace of explanation, but I hope by now you have built a strong foundation to understand the further concepts little quickly. All right, I'll put the timer on. See you in 5 minutes. Hello, everyone. I hope everyone is back from the break. Let me open the Microstream slides. At least by now you have idea about what are service classes, what are controller classes, right? So I think you will be good to understand the Microstream part also. The project, Spring Boot Microstream project. Let me check whether these are the correct slides. Yes. Okay. So let me introduce Microstream technology to you. So Microstream is a next level serialization framework. So let's first talk about Java. Java is a predestined environment to realize high performance in-memory data processing. So Java provides a first-class native multi-model data structure, which is called as Java Object Graph. So this is your application. Your application stores the data in memory, which is in your RAM. So it's stored like an object graph. And this is your Java virtual machine. So this is a layer between your application and your Java virtual machine. So Java object graph, you can design your object graph freely. Like you can create any classes, right? So that is called design your object graph freely. Adapt it seamlessly to your business requirements. Use any Java type. Like you can use a custom Java type also, like you saw for instructor name. I used full name, custom class type. Use collections, use object references, use circular references, use inheritance, use third-party libraries. Only one data model, which is Java Pojo classes. So for Microstream, they have focused on only one data model, which is Java Pojo classes. You don't need to have entity classes or anything else. With simple Java Pojo classes, you can store your data and fetch your data. So the query language to search Java object graph is what? Is the Java Streams API. So whatever objects you have stored in your RAM, you can access it with Stream API, right? For example, here, books by author. You can use this Stream API, right? And collect that data. Readme cop.data.books.stream.collect, and it will group by book author, and it will get you all the books by author. Like it will group all the books by a particular author and create this map for you. So this is how it works, and then we are just simply printing it out. So this is how you can query the objects which are stored in your RAM as Java object graph. Let's talk about persistence. What about persistence then? So when we talk about persistence, persistence means from your RAM, now you want to store it to some database or some other data storage, right? Like storing objects into tables or JSON kind of a database, or key value stores or graphs. So this conversion has to be done. So data is stored in your RAM as an object graph. From here, data has to be converted into some other format before it can be stored to a particular targeted data source. And this conversion is what requires a lot of CPU power, reduces the performance of your application, expensive latencies, complex architecture, expensive development process, inefficient concept, requires expensive cluster infrastructure, increase your cost of infrastructure. So these are the challenges of data persistence. Even though reading data from a local cache, mapping conversion is mostly required. So data which is stored in your RAM, even though like even if you're storing, let's say before storing here, you have a local cache. Even if you're storing data here, even for reading data from here and like storing, bring it back to RAM requires a certain kind of a mapping and conversion. So it also has a certain cost associated even if you implement caching. So you can imagine this problem is not solved, not even by the NoSQL database, not by the graph database or this OO database. So all these are not compatible. So they are incompatible with native Java object graph, which is stored in your RAM by the Java application. So there is a impedance mismatch. So this is called impedance mismatch. Let's let's see this system prevalence. In a system prevalence, your Java application is storing your Java object as a Java object graph in the RAM, and then JVM is converting it and storing it to a file storage or to any kind of a storage. Okay, and then again, when you are reading from your file storage, you again have to read it, bring it back to JVM, convert it to a Java object, and from here your application reads and you can read it properly. Now, in this general system prevalence, what are the various weaknesses and challenges in this approach, in which you have this object graph which gets stored, which gets converted and stored to some external storage? So the general weaknesses are, what if you want to take a snapshot? So there is a snapshot problem, snapshot time, long system restore time after restart is not suitable for microservices, risk of losing data between snapshots. Okay, one more thing, very important thing, which you must have observed. Max database size, if less than RAM size, then your application breaks. Now here, where is that diagram gone? Okay, now here, let's imagine rather than file storage, this is your database, and you have stored a very large amount of data in a particular table. And if you're trying to fetch all that table data back to your RAM, and if your RAM size is less than the size of data which is stored in that table, your application will hang, right? So this is what it means by max TB size is less than your RAM size. So these are the weaknesses in system prevalence concept. Then big RAM size is required in general for your application because of the system prevalence that is in place. Extremely huge traffic, high infrastructure cost, garbage collector issues lead to latencies, because the data is getting stored. So the garbage collector has to kick in and free up the storage and again store the new data. Class changes, like if your class changes, the database table columns also have to change to store that new fields. Java serialization limitations and issues. So you must be knowing the Java serialization limitation, right? The limitation is that we have to implement that serializable interface. And if you're using a third-party library, and let's say that guy, whoever developed that library, forgot to implement the serializable interface, in that case, you cannot serialize that particular object and store it, right? That's the Java serialization limitation. So Microstream eliminates these weaknesses of the initial system prevalence concept. So what it does is basically, it adds this Microstream layer here, and it directly stores this object graph without any conversion inside your targeted file system. So that is what these guys have achieved. Okay, this is what is achieved by Microstream. So streaming objects directly into any database, conversion eliminated. The biggest problem or the performance issue was conversion. It is actually right now also people are using normal things, which is a problem. So Microstream has eliminated this data conversion here, but this is only supported for Java or JVM based technologies. Now the architecture is simple, faster time to market, saves a lot of CPU power because there is no conversion required. It is directly able to dump this object graph without any conversion as a binary into the file system and read back that binary and again store it to the object graph without having any conversion required. It saves a lot of CPU power, minimizes latencies because conversion is not there, so latency is not there. In-memory queries executed in microseconds. In microseconds, you know that, right? With Java streams, you have the data in stream binary. So it's in-memory queries. The data is brought back to your RAM and queried from there with help of Java stream. So it is executed in microseconds. Then saves up to 92% cost of infrastructure, because now you don't need any expensive infrastructure. You can directly dump the binaries into any kind of infrastructure that you have, a database or S3 block storage or anything that you like. Okay. So this is a repository. You can just go to GitHub to this repository Microstream -1 Microstream. Here you can get the sample code for using Microstream. You can also go to Microstream.1 documentation to refer to learn about Microstream. And This app Microstream runs wherever Java can run. It can run in your desktop, it can run on your premise servers, it can run in the cloud, in the container, in JDK 8, Android, microservices, and native image with GraalVM. So use any JVM technology. You can use any JVM technology, be it Java, be it Scala. Scala is also a very good programming language. It's object-oriented plus functional language. You can use Kotlin. If you're an Android application developer, then you'll have to learn and use Kotlin, because Play Store is owned by Google, right? Google Play Store. So they have promoted the use of their own language for the application development, Android application development. Then you can use GraalVM, Clojure, Android, Scooby, anything that you like. So how does the data model looks like? It's a simple Java Pojo class. So you can imagine you have this customer class here. It has his first name, last name, email, date of birth, active, and orders. Just set of order. Just give me a moment, I'll be back. All right, I'm back. So your data model is just Pojo classes. So how does the data structure in Microstream looks like? It's just your simple Java Pojo classes, which can be directly stored from your RAM inside your storage. Okay. So data model is Java classes only, no dependencies. You don't need anything specific like JP or anything. No specific dependencies, just Pojo classes. No need of special super classes, interfaces, or annotation. Use existing classes as they are, no string attached. Any Java types are supported. Use any types from third-party APIs. So this serialization was not possible before, but it is possible with help of Microstream. Design your object model freely without any limitation. Use inheritance. Using inheritance is trouble-free. Migrating to Microstream itself is trouble-free. Okay, persisting objects. So this is the code that you have to write to persist an object in the current directory of your project. So you can store a single object or a subgraph of an object explicitly. You can store any Java type, any suitable format. Okay, any suitable type is supported. All types are supported. You can use inheritance, binary data format, no expensive mapping, atomic operation. This is what concerns when it comes to storage. So it is asset transaction safe. Strong consistency, append only log strategy, multi-threaded write operations for max performance, gigantic data throughput, custom tailored type handling for best performance, replaces 3 CRUD ops, create, update, and delete. So this is how it works. In multi-threaded, you can read from 4 different microservices like binaries, which are stored at 4 different locations. You can directly read from there using this Microstream layer by using Microstream dependency in your Java project, and load these binaries without any conversion required into your RAM. Loading objects dynamically into RAM. Okay, dynamically means what? When required, that time loading those objects. So for doing that, you can use this lazy class is there. With this lazy, this set of order will be loaded only when get orders method is called. That is the use of this lazy class over here. So because you are loading only the required data into the RAM, so sufficient RAM will be available. Restore the entire object graph when you need it. RAM limited, RAM is always limited. So load single objects or subgraphs on demand. Loaded objects are merged into the object graph automatically. No inconvenient object copies. No more classic select, simply call getter. Minimizing expensive IO ops. Multi-threaded read ops for max performance. Gigantic data throughput. Memory management. So memory is fully managed by JVM. You don't need to worry about any cleanup or anything in your RAM because it's a JVM based technology. Use lazy references if possible so that you dynamically load the data and keep your RAM available as much as possible. Clear your lazy references when which are not used anymore. In case of garbage collector issues, if you face, Microstream recommends using Azure JVM. Note, your object graph is your in-memory database. So when we say in-memory database, we are referring to this object graph which is inside the RAM. So we can directly take this without any conversion in when you're using Microstream, without any conversion, store it to any data storage, be it DBMS or plain files. I'm going to demonstrate plain files in the example that I've created. And if you're using JPA, in that case, what you have to do is you have to map this data object to an entity, and you have to convert it into a database format and then store it. So that's the expensive part, which is the conversion part, which orange part you see here. That's the expensive part, the conversion. So Microstream is lot faster than JPA. If you want to get started with Microstream, you can learn Microstream from here, from microstream.1. This is the Git repo. This is the docs and the videos, and everything is here. Let me just copy and send this to you over the chat. You can refer these links and get started with using Microstream in your office projects. All right. So that's about Microstream. Let's see the practical example. I'll just close all these tabs for now. Let's mark it. So we have done till module 10 today. From tomorrow, we'll continue from module 11. One more thing. Let's get started with the Microstream Spring Boot project. This will give you a better idea. This is the Microstream Spring Boot CRUD Operation project, which I have created. Again, it's a Spring Boot application. So here you can see the version of Spring Boot that I've used is 2.5.5. The dependencies that I've used is the Microstream dependencies first. These are the two Microstream dependencies. Microstream storage embedded, and this is the version. Microstream storage embedded configuration. These two dependencies, and the web dependency, DevTools dependency, Lombok dependency, test, and the Swagger dependencies. Then this is the base package. This is the main file, a simple Spring Boot main file. This is the Swagger config. This is the Swagger config, which you're already familiar with right now. And here you can see I've provided the controller package name. This is the controller package name. Inside the controller package, I have the student CRUD controller. Here, this is something new for you. Student repository. I've just auto-wired the student repository. Let me show you the student repository. This is our interface, and this is the concrete implementing classes. And inside this, we have the main thing. Let me expand the entity package also. Although we don't need to name it entity, we can just name it .model because it's a simple Java Pojo class, right? So let's rename it. Refactor, rename. Let's rename it to model. All right. Now here in the student repository IMPL, you can see that it is implementing student repository. Here we have list of students, and we have the embedded storage manager object over here. And here what we are doing is this is the constructor. In the constructor, we are initializing the embedded storage manager. So this is how we initialize. This is the code to initialize the manager. Embedded storage dot foundation path dot get location on connection foundation. This is this is just a kind of a functional code. Inside you can see it's a consumer functional interface. CF dot set class loader provider class loader provider. This is the configuration code. Don't worry too much about it. All you need to worry is basically create this student class with your fields. Okay. And just write this code as it is, this part, and in the end just write the list of your storage. So we want to store a list of students by using Microstream, so just pass it over here. That's all you need to remember, and just initialize the array list for your students like this. And the value, like where this list of students, the binary data will be dumped is in this location. So I've added this property and I'm importing this property with help of the Spring Boot annotation @value. So I'll open the property file. Here you can see the location. Inside my user directory, I have this folder, Microstreams Spring CRUD store. Inside this, the binaries will be dumped from binary will be stored. And whenever I want to fetch students, the binary will be again loaded back to the RAM. Okay. And simply by using now this like this storage, I can store students. I can basically add a single student or add multiple students, find all students, find student by first name. This is how we can easily query, find student by last name, delete all students. Okay. Any questions before I demonstrate how to basically run this project?
So, hi, Samarth. I have one question.
Yeah.
Hello.
Yeah, I can hear you.
So my question is like, is the Microstream can be replaced of some sort of like caching? Can we replace caching with Microstream?
Not just caching, you can also replace your data storage or persistence with Microstream. It is much more faster. You can check this out. Like, I'll show you how. Go ahead.
No, I mean to say, like, is it faster than cache data? Because
Yes,
when we like use Redis, right? The older version of Redis, where we used to have that the fetch or data used to fetch all the data, right? Is because it dump as a string and fetch as string, right?
Correct.
So will that be a faster I mean to say that will that be a faster implementation for the fetch, where I want to fetch single data instead of fetching the whole data?
Exactly. It is 1000 times much faster for fetching and for storing also. And it saves up to 90% of CPU power and cost. That's why Microstream guys are training people to learn Microstream, because they know the power of this product.
Okay.
Yeah. Not many people know in India. In Germany, it's widely used. In India, I think actually the videos of Microstream are in German language on YouTube, majority of them. Because of that, I think people are, finding it difficult to learn. So I learned it by reading the documentation and I created this project.
Okay. Thank you.
Just go through the documentation and you'll also learn about it, like learn more.
Sure.
Yeah. That is how I learned and I created this project. Okay. Since I've enabled.
Samarth, just one query.
Yeah.
The data that we're persisting here, it will be file storage, or how the storage is maintained?
Yeah, data will be stored in this location. The binary data will be dumped in a forum. In the binary data, like your object graphs will be directly dumped there. So let me open that. I'm opening this path. It will be dumped here. Right now, you see this folder is empty.
Yes.
Let's start this application. Let's dump some data in. I think let me just refresh the project structure. Yeah. Sometimes if you see a wrong packaging structure, that's an Eclipse problem. You can just refresh the project. I just refreshed by pressing F5. You can do right click and refresh also. Okay. Let's start this application. Okay, our application has started and it's running on port 8080. I think we have closed all those tabs. Let's close all these tabs for now. Let's open a new tab. Let's write here localhost /swaggerui.html. So here you can see we have the student CRUD controller. Let's add a student. The first name of the student will be Samarth. The last name will be Narula. Student number will be 1. Let's add one more student, Kiran Reddy. Student number will be 2. So we have added 2 students. Here I have printed students added successfully. Let's find all students. Here you can see I'm able to find all students. So all this data is stored here. You see we have this channel 0 now. We don't need to worry about it. The Microstream framework is designed to store your binary data to this path and to load the data from this path back to your RAM. Okay. That is what they have achieved. That is why they are next level serialization framework. Okay.
Disadvantages of using Microstream.
I'm not aware of any disadvantage. I don't see any disadvantage.
I just got curious about it.
To get data. Sorry.
Mm-hmm.
Is it possible to fire complex queries or get data by?
Yes. Because all you have to do is write Java stream, use Java streams. Whatever you can do with Java streams, you can do here. Yeah, simple Java streams. All you need to know is Java stream. No knowledge required of any complex query language. No stored procedure required. Nothing required. Simple Java stream to query your data.
Samarth, I just have got curious. Like the data that we are storing here can be accessible only via REST APIs, right? There is no other integration possible, right?
No. There is. You can write a normal Java main method also to access it.
Yes. Yeah. Comparing it to the traditional persistence storages like databases, that might have other integration to like ETLs. They might have some different integration, but to expose the data. But here in this case, the only way
you have to write through Java. Only way is Java.
Yeah. Only way to expose the data is through Java and APIs.
Correct. That's true. That is why they mentioned, right? It's a JVM based language. It's supported at all JVM platforms. Java or Kotlin or Scala, only JVM based. Okay, not Java. Java I'm saying because I use Java in JVM based languages, and before I've used Scala also, but any JVM based language it will allow to query, okay, and to store.
It's not free of cost, right? I mean, we have
It is free. It's open source. It's free. Anyone can use it.
Even for enterprise level use?
Yes, it's free. Only thing you have to do is add these dependencies. That's all. It's free, completely free. Okay. Find by first name. So what was the names I had stored? Samarth. Let's find by Samarth first. Now I have not ignored the camel casing part, so it will search by Samarth only. If I write this small s, it will not give any result. Now let's search by Kiran. You can see that I'm able to search. Query by last name. Let's say Reddy. So you can see I'm able to fetch Kiran Reddy. Store all if you want to store multiple objects together. So you can just store it like this. Something else got copied. Now just provide the names. And click execute. Okay, it's giving some error. I think I made some mistake.
Semicolon after the second code.
Yeah, this is the mistake, correct. So all data stored. Find all. Able to find everything. Delete all. Deleted everything. Now find all. Nothing will work. CMT. So I've created this project. You can use it as a base project and learn Microstream, because building this base project was very difficult, because initially I had to go through the documentation, read everything and build. But since you have this base project, you can build on top of this. Let me see if I've added to my Git repo. Yeah, I've added it. You can refer from here. Okay. And I'll also share my LinkedIn profile with you in case, if you want to reach out. Where is it? If you want to reach out for recordings or for application code specific thing, you can drop me a message. As soon as I get time, I'll reply here. Okay.
So will this recording be available?
This will be available with the Microstream guys, and they will send you over the mail. Maybe immediately or within 7 days or in 1 month. If you don't receive, you can follow up with me on LinkedIn. I'll follow up with them. Or you can first of all drop a mail to them and ask them. If they are not able to respond because they're busy, so you can reach out to me. I'll I'll get it for you. Like get it on your mail ID.
Okay.
But I don't receive. This is not my Zoom account. This is Microstream Zoom account. So it goes to them. So don't worry, but I'll get it to you. Last year also, students who had not received, they reached out to me on LinkedIn. I had a word with Microstream guys and they sent them. Okay. You have the projects, but it's on GitHub. Main thing is you have the project. And you have tomorrow's session also. Go through the code, come up with your doubts, and I'll clear it. Okay. This is it for today. We'll meet tomorrow. Before we wind up, let me show you the curriculum for tomorrow.
Please share the Git repo link here in the chat.
Okay. Yeah, I think I had shared this today, but I'll share it again. One more thing I wanted to show is this, what we will study tomorrow. So day 1 is done. First, let's summarize what we have done today. Then we'll discuss what we'll do tomorrow. So today we have learned all these things, which we had, not everything actually. We had learned till module 10. So we are done till here. Now tomorrow we'll finish from module 11 to module 16. Module 17 is also done, right? We have done this Microstream module. So done till here. Okay. So tomorrow we'll study these modules first, these remaining 6 modules like 11 to 16. And then we'll start with Hibernate, in which I'll teach you all the mapping annotations and everything. Then we'll build an audit system. And along with that, we'll learn the use of Spring AOP and what exactly is aspect-oriented programming. And then we'll learn Spring security. And then if the time permits in the end, we'll cover the Spring Cloud module configuration management, like how you can externalize and place your configurations on GitHub and manage them. Okay. So these 3 are very important, and this also will cover. But whatever I'm teaching, the main thing, my focus is that you should learn whatever you like is covered. Exactly, you should learn it in and out. And covering the complete module if it is started. So I think everyone is clear for today, right? If you have any doubts, this is the good time to ask, like before we end for the day. If no doubts, I'll just keep this last 5-10 minutes for any doubt clearing. And if you have no doubts, you can drop off. We'll meet again tomorrow at 9 a.m.
Same link.
Yeah, sure. Go ahead. Okay. I'll keep the call on for next 5 minutes. If anyone has any doubts, you can ask.
Samarth, do we have any cheat sheet kind of thing for all annotations?
For annotations, I have not built any such cheat sheets, but the projects that I've built act as a base projects for building those things.
Okay.
So it's kind of a more of, you need to remember these annotations, and you can then use this project as a base project and build anything in Spring Boot, like any API product. If you have a unique idea, you can implement it and create an API based product, or maybe a backend for a front end project, like for a complete full stack project, backend and database design.
Okay. Yeah, thank you. Okay. So tomorrow you'll be covering security also, right?
Yeah. First of all, the remaining modules, the embedded database, entities, JPA, exception handling, exception handler, and along with that, the advanced concepts like Spring Security, Hibernate, and Spring AOP, and then Spring Cloud Configuration Management.
Thank you. It was a really nice session.
Okay. You're welcome. Good to have you. See you guys tomorrow. Thank you, everyone. Thank you for joining.